So good evening, everyone. So we welcome you to the day 5 of FDP. So it is my privilege to introduce our distinguished speaker, Mr. Abhijit Mohapatra, Principal Member of Technical Staff, AI and ML at Athena Health Bangalore, and a leading expert in machine learning and data science with over 14 years of experience across diverse industries. So Mr. Mohapatra has an outstanding track record in designing, architecting, and managing large-scale machine learning engineering solutions for clients in finance, legal, retail, semi-manufacturing, and high-tech consumer electronics. So his professional journey includes collaborations with global leaders such as Apple, Sony, Disney, and Citibank. So over the years, he has successfully delivered enterprise-level data science models and machine learning pipelines that have powered critical business decisions and generated billions in operational efficiencies. He brings deep expertise in data strategy, product development, cross-functional collaboration, and in building highly scalable, low-latency ML solutions. So his work spans the entire product development cycle from ideation and prototyping to production deployment, enabling organizations to transform actionable insights. And in addition to his corporate achievements, Mr. Mohapatra is an active contributor to the open source community and dedicated mentor, guiding teams and professionals in engineering, AI and ML, and analytics best practices. So we are truly delighted to have him with us today to share his insights on AI, ML, and data-driven innovation, and to guide us through a practical applications that drive measurable business impact. So please join me in extending a warm welcome to Mr. Abhijit Mohapatra from Athena Health. Over to you, Abhijit.
Thank you. Thank you so much.
Welcome, sir. Welcome.
Thank you. Thank you, sir. Thank you for the kind introduction. I hope I'm audible to each one of you.
Yeah, Abhijit, you're good to go.
All right. Without further delay, I'll quickly start about the agenda that I'm planning to discuss, and based on that, we'll have some hands-on sessions. So the first thing that I would like to do is probably uh, take you to the quick demo of what is actually happening with the healthcare space and the state of the algorithm that we have been using, the solution that we are using as of today's date to handle or probably deal with medical cases or the kind of use cases that. And post that, we will be probably going through a hands-on on the kind of a problem statement that we will be working out towards, like mostly not towards jumping immediately into the solutioning part, but rather it would be like a thinking process of how do we approach a machine learning problem statement in the first place. I do understand that here the audience is coming from different diverse backgrounds, so I empathize with the tech stack skill sets, and I'll try to lower the ball, but still making sure that we get benefit out of this particular sessions. So towards the end of these sessions, my core objective would be that, okay, this is a problem statement. This is a real-time use case that we are looking at, and probably this is how I would approach a machine learning problem statement, and this is how I'm going to be solutioning it, and this is how what it looks like in a machine learning problem statement. So this is how I'm planning to take forward. So let me quickly share my screen. Just give me a minute. Here we have all the ones. Yeah. So I have multiple screens, so please bear with me if I'm not looking directly to the video. Doesn't mean that I'm not paying attention, but I have multiple screens over this, please. So please bear with me. Let me quickly put my screen. All right. I hope you guys are able to see
Yeah,
my
Bijit,
screen?
we are able to see your screen.
Awesome, awesome. So let me also zoom in. So what you're looking at is like some kind of dashboard, something like what is happening here. I'm seeing some kind of text here. What is exactly is happening? Can someone help me with this? This is the kind of question that come up with when I talk to leaders and what exactly you're trying to do. So basically, what I'm demoing you quickly in the interest of time is that I'm trying to build a kind of a patient doctor appointment kind of an application completely using an agentic AI kind of solutions. When I say agentic AI is basically that I'm going to query the applications, and based on my requirements, based on the query, it's going to call the GPTs, and based on that, it will try to do all the needful necessary actions. So what you're looking at is a very complex problem statement here is
Abhijit,
that,
sorry to interrupt. Could you please zoom in little more?
yeah, sure. So please let me know if this is visible now.
Little more, please. Yeah, now it's better.
Is it better? Okay.
Yeah, it's better.
Okay. So here it is saying that, hey, I'm feeling confused about my medications and recent test results. I need to refill my diabetes medications. My prescription number is so and so. And I also want to understand my blood results. So this is my lab results ID. I have some allergic situations and conditions. So I would also like to understand if the two medicines are having any kind of chemical reactions with my body. So metformin and lisinopril. So here it is also saying the allergic conditions. I'm also saying that, hey, please also see this is my patient ID. And this is my imaging results or the lab MRI results, something like that. Please also make sure that you look at it and let me know how can you help me with this. Now, if you look at this simple query, so this has got multiple requests. It is asking me to refill my medicines. It is asking me to go for my prescription number and get whatever medicines that is being due. It is also asking me to get me the lab results. It's also asking me to go get me the imaging results. And here is my patient ID. So there's multiple asks that's been there. Now, how do I understand where to get what data? Because for prescriptions, it's in the prescription database. For lab results, there will be a lab database, and imaging results will have in the imaging results or imaging database. And for medicines prescriptions, the medicines information, the lookup for the medicines will be in a different tables altogether. Now the GPT is going to understand what is your ask, and then it will try to break it down into multiple subtasks, and then it will make those needful calls. So what it does here in the GPT is that it is able to break it down. So if you could see that it started analyzing the query, and it is able to break it down into like 5 different small tasks. Here it is saying that, okay, I need to refill the medications. Here it is saying that also I need to extract the blood results. I also have to understand the drug interactions between the metformin and the lisinopril. Likewise, the imaging results, and I have also shared the patient ID. Now, with this, what happens? It is able to understand that, okay, this is basically to do with refilling, ordering kind of a fulfillment request, and it is nothing to do with the inbox management or scheduling an appointment with the doctor. So it is able to understand those part of the query, and it's able to redirect, okay, this is what I have to do. So at first, it looks like, okay, it's a very simplistic stuff, and GPT should be able to do this. It's a very simple query. Once it is able to break it down, it should be able to make all those calls to the GPT, the database as well, same times. But if I may take you to the overall architecture diagram of this particular part. So this is what it looks like in a complex environment. So every the oval size, the yellow color sized oval that you are looking at, these are all agentic AIs and very complex kind of a design patterns that we're looking. This is more of like a supervisor kind of a router design patterns, which is being routed by or powered by GPT-5. Likewise, there are other agents which are being powered by GPT-4. You can also collaborate with Gemini and also Llama based on the kind of use case. For example, like asking what is diabetes might not need a very powerful model in the first place. So we can lower the ball down. So maybe we can be okay with the GPT-3 or probably low scale Llama models. But healthcare order agents is a very complex use case, or probably kind of a complex agents because it has to understand a lot of things. So probably I'll have to put up a very complex design patterns here. It's a kind of a self-reflection design pattern. I know at first it may not make sense to all those jargons that I'm talking about it, but if I have to put it in a very layman language, so this is the agentic AI world that currently is in use in the real-time production environment, and every other company is actually trying to create a kind of an agentic AI kind of solutions. So here at Athena Health also, we are also trying to do something for this kind of requirement for our doctors, and so that they can be able to leverage more of this particular app. So with this, the idea that I wanted to pass on is that uh, the use case, if you see here with respect to the query that is being done, sometimes it is too advanced for the classic machine learning or deep learning model to come up with, because there is no labeled data as such. This is a pure, raw, simple query English language. And if we have to train kind of a classic machine learning models or probably deep learning models like CNN or LSTM, something, what happens, we don't have the label informations. And here in the real world, we actually work with a lot of unlabeled informations, and there is no labeling, there is no tagging or annotations of those information in the first place. So in order to deal with that, GPT is one of the solutions, but there are other kind of solutions are also there, using Gemini, using your BERT-based models, which you can end up fine-tuning. So I'm also involved in kind of like fine-tuning some of these complex large language models on our GPU drivers on using CUDA kind of programming-based style of it. So with that, what I wanted to send out a message that this is the state-of-the-art kind of features that we are currently using with, be it be finance use case, be it be retail use case, or be it be healthcare use case. So this is what we are trying to do. So with this, I will take you further to explain you the kind of the hands-on sessions that we planned for this, so that at least given a data sets, how do we approach this kind of problem statement in the first place, and doesn't has to be GPT kind of a problem. So the core idea is to help you give you a feel or a texture of how the machine learning problem statement works. So I have a use case which is like uh, breast cancer Wisconsin data sets. And I'm actually referring.
Sir, if you can please magnify your screen. There was some chats that it's very small to see. If you can magnify it, yeah.
Sure.
Yeah.
Let me. Yeah, I hope
Yeah,
this is better.
this is fine.
This is better? Yeah, okay.
Yeah, fine, sir.
Okay, so I kind of post this also on the chat window if people can find it useful. Okay, maybe post, I'll be able to post, just share those links. But what I'm trying to say is that how do we get started with kind of a machine learning kind of problem statement? How can I get real or probably curated data sets to learn or apply different kind of algorithms and statistics or machine learning algorithms in the first place? So here is one of the website, which is UC Arvin Machine Learning Repository. So here we have different kind of variety of data sets. So it's related to healthcare, it could be related to iris data set, or it could be wine quality data sets. So this is one of the place where we actually started. I mean, at least I got started when some 15, 14 years back, when I was actually started to learn about this space, that what exactly is this data science in the first place, or what is this data sets do that, what is those statistics and algorithms do that. Though I was able to understand, I was able to process this data in a magnifying scale, but for the algorithm to work or what algorithm works on what situation, so I need to start like working out those small use cases. So this is one of the place where this is very popular data, and it's a very rich data set. So you can always uh, log into this particular URL and start working on one of the data sets. So it also talks about what kind of problem statement can be solved with kind of this particular. For example, wine is basically classification and it's a tabular data sets, and talks about 178 instances, and there are 13 features. The one which we are going to cover is probably the classification one data sets. It's a multivariate kind of multiple variables kind of a data sets. It has got 569 records, and there are 30 features. 30 features. So if I just happen to click on this particular data sets, it will take me to this particular new page where it talks about, okay, what is this page talks about more about this information. So this is basically talks about that Once you go into the feature side of it, some of the features will make sense, will not make sense, but it tries to tell you that given a nucleus, say, of a tumor, and if you happen to measure all the metrics with respect to that particular tumor cell, so for example, the radius one, the texture one, or the perimeter area one, we need to understand, given these are the fields, these are the informations that is available at hand, does it represent as a malignant kind of a tumor or is it benign kind of a tumor? So is it a dangerous or it is a non-dangerous tumor? So these are the kind of informations that it gives. So once you keep Googling around it, you will get even more kind of informations around it. It will also tell you that what are the accuracy, what are the models that has been used to actually come up with the prediction, which is giving the best way, which is giving the not, which algorithm doesn't work out in this case. So it gives you kind of an overall picture that, okay, this is what it looks like. I will also tell you how we kind of like download this data sets and how can we work on this data sets. So, but just to give you to the problem statement, making you familiar that we are going to work on breast cancer Wisconsin data sets. This data set contains around 30 features. There will be one labeled information, talks about like whether it's a malignant or a benign kind of a tumor, dangerous or non-dangerous. And it has, and these are the kind of features, whether it's a categorical features or a continuous features. I know those terms could be non-familiar also or familiar also to some of the people, but categorical features are like basically um, yes or no kind of something like that. And continuous features mostly will be kind of a decimal kind of a way of putting it across. So those are some of the like radius or in centimeter, those kind of measurements will come into the category. We'll go deep into it once we get familiar about the data sets. I'll also show you the Jupyter notebook. I think I have also uploaded the Jupyter notebook in the respective folder. Feel free to download whenever you have the meantime. So yeah, so that is one thing. I probably will take you to the Jupyter notebook. Let me understand if the audience is able to download the Jupyter notebook in the first place.
You have shared the Python script also in the folder, sir?
Yes, I did.
Yeah, okay. If we want someone, they can also work alternatively, or after your demo, they can work.
I think they can work alternatively and can work with
Okay.
me also.
So any of you, if you can access the folder of Mr. Abhijit, he has posted in the DAY-05. You can access the data as well as the collab code. You can just run it. Okay. You can also come out with the doubts. Simultaneously, you can also do that.
So this is the Jupyter notebook. Let me also zoom in for better visibility. So this should be by this name, Breast Cancer Predictions Collab Jupyter notebook.
Abhijit, could you please zoom in a little more?
Okay. Is this better, Anu?
Yeah, better.
Awesome. So I'm sure most of you are very familiar with the Jupyter notebook. If not, once you open this Jupyter notebook, we need to connect it to some kind of runtime environment like Python interpreter. So I'm just connecting it to, I just clicked on this right side connecting. So connected to hosted runtime. So it will connect. So once you connect, it will be able to say a green tick mark, which says that it is now connected. So in this Jupyter notebook, one thing that I have deliberately done is that I will try to build a story and tell that, hey, there are 30 features. I did a statistics on top of this data set. I could find that there are 10 to 12, 15, or probably uh, good variables or features, which is more important or which has got more weightage over the other uh, remaining 20 or 18 features in the first place, or variables in the first place, or columns in the first place. But then I have applied a different kind of concept towards the bottom of it, which kind of like tells that sometimes we have to drill through the data or understand the data or tell a story with the data to such an extent that sometimes we feel those features are not relevant, but they actually helps us to improve the accuracy of the model. The other side of this story is also in the production environment or in the real-time use case. Given that this data set is very small, sometimes when we start using deep learning models on top of it, given that data set is very small, it may kind of overfit because we need very large amount of data sets for the neural network kind of models to begin with. So um, if you are able to open it, we can proceed further. So should I expect a kind of a thumbs up if people are able to open so that I can proceed further? All right. So I got one thumbs up from Mr. Vishwajit. So I assume that people are able to open it. So once you open this, I probably have to install the packages, relevant packages that is needed for this. Yeah, definitely. I'll explain from the starting. Definitely, I'll also expect you to also to give a kind of a thoughtful thinking into what is happening with the code, why we have done it in the first place. The solution is not more important. It's more about the why we did in the first place and what are we going to take away from it in the first place. So, um, so given that covered the breast cancer data set, I will try to cover that part once we scroll little bottom when I'll show you the real output of the data set in the first place. These are all kind of text which have been written by myself, but this is also to tell you that these are just not the only 12 features we are talking about. There are almost 30 features, and a kind of a misleading way of telling you that if you just focus on these 12 features, this is not going to help you to the solutions. And when you actually deal with a project in a real-time environment, we do not get much of the input about what that data talks from the product team, also from the engineering teams also. So some of the data analysts, they also do a simple SQL query and populate the dashboard for us, but they don't help us to explain why this field or column is super important over other columns, and any change with this is going to impact our end results. So that's where we have to explain this to our fellow data scientist community and the data analyst and the product managers, that why this particular columns is super important. So that's one of the idea. But yes, given that rest, I'll just cover about this. We have an ID, we have diagnosis informations, like I said, radius, texture, perimeter, area, smoothness, compactness, concavity and concave points and symmetry and fractal dimensions kind of features available with these data sets. So here we're expecting around 30 features. I have categorized into worst and mean and other informations, which we will cover in the later part of it. But we can still ignore the lot of text here. But most importantly, coming back to this particular part, so we need to install this package. Let me try this out. So once I did I'm in my MacBook, so I used Shift Return. So in your Jupyter notebook, feel free to just click on the button over here. It will start running. So once I click on this cell, I'm installing NumPy, Pandas, and Matplotlib, Scikit-learn, Seaborn, and UCML repo. So this particular repo is going to help me to connect with the UCI machine learning repository datasets. So I'm not going to download every other data sets using some kind of URL or request package or into their website. But rather, they have provided a kind of a library. Using this library, I can directly use their APIs to actually inherit all those data sets into my workspace in the first place. I do have called out XGBoost package here, although I didn't feel the need of this using this XGBoost because the basic algorithms sometimes are able to reach a very high accuracy. XGBoost was not giving that additional boost or increment in the accuracy part of it. But at the same time, it's a super expensive process. So I thought like maybe I'll just keep it for now in the package, but it's always, you can always feel free to try that experiment once I start covering the other part of it. So yes, now you could see that all the packages are installed. So you should be able to see that successfully installed all of these packages. I hope you guys are able to install the packages without any challenges. And if people are able to run or able to install those packages, feel free to proceed further with setting up the libraries and feel free to go ahead also with your understanding. And as in when if you have any doubt, feel free to post in the chat window. I'll try to answer those questions. I know the batch is very big, so it will be difficult to mute each and everyone and get the questions. So feel free to put up your questions in the chat window. I'll try to answer as and when. But in the meanwhile, if you wanted to speed up, yeah, that's absolutely fine. All right, I'll just move ahead with loading those libraries. Now that I've installed all the packages, so I should be loading those libraries straightforward. So it started running. I have given so many algorithms for your like key neighbors classifiers. I'm not using any of this one, but feel free to use this um, libraries or the algorithms, machine learning algorithms, post this sessions on the same data sets to see yourself that um, how does it perform against other kind of machine learning algorithms in the first place. Here, this part I have commented it out in case if somebody is willing to save this into their environment, kind of save this CSV file of breast cancer risk consent data sets. This is one of the packages, probably the libraries, probably the code snippet, which I have commented it out. Feel free if you want to uncomment, but not in these sessions, but definitely once you take it back to your laptop system. Now coming back to this particular part, this is slightly tricky part here. So what I'm trying to do is I'm trying to fetch the Wisconsin data sets. You can see that I'm using fetch UCI repo, which is definitely from the UCML repo library. I'm saying that it is ID 17. How do I know that this is ID 17 or ID 97? So if I go to the official website of the breast cancer Wisconsin dataset, there is this something called import in Python. So once I click on this, it will open up the necessary package to download this dataset and the code snippet to do that. So here it says that ID 17. So I have bought this code snippet from their official website and I have posted it into the Jupyter notebook. So that's where I got this information. I'll just keep it open for some time for you guys to see this. I'm also zooming in. So far what we understood is, yes, you are talking about the link. So basically, if I go back to this Jupyter notebook, I'm trying to fetch this Wisconsin dataset. And I'm using this function. I'm giving this parameter. How do I know this is 17 or 97? It belongs to breast cancer risk consent dataset. Now, if I go to their official website, which is where I could find the breast cancer risk consent diagnostic dataset being hosted in the UCI, there is this import in Python link is there. I'll zoom in here. You can download this onto your MacBook or Windows system, but you can also directly import it into your workspace environment, Google Colab or Python script also, without having to download in the first place. So there are two options. So let me, yes, here is the link. And here is the script. So now if I run this, this got downloaded or probably fixed. Now I just happen to understand my features and the label data. Now, if some people are not very familiar about it, so let me put up a very simple layman language. You might have heard that popular use case where I show or I train my model with cats and dogs picture. The model learns all the features or the attributes or the traits of cats and the dogs. And then once the model learns all those features, if you again come back and show, hey, can you recognize whether it's a cat or a dog? It shall be able to do that. How does it do in the first place? So basically, we talk about features of a cat. The cat's facial features are totally different from a facial features of a dog. So they have different kind of a shape, diameters, nose and whiskers and every other things. So likewise, if we are trying to understand that given these are the measurements of a tumor cell, we should recognize this as a malignant or a benign. So when we say we are going to recognize this versus this, which is saying that these are the label data. That's my Y. That is what we are trying to predict. And all those columns, which helps you to derive or drive you to that decision-making process, that whether it's a tumor, dangerous or not, those columns are in fact called the features in the first place. I'm sure most of you guys are very familiar with this. I'm just trying to revise those concepts one more time, and probably this can be helpful for other people who are very new to this space. So here, what I mentioned in the very beginning is that this particular data sets that we downloaded from the UCI has got around 30 columns, or maybe we can say with diagnostic. This is the only the features part of it. So these are all 30 columns, and there are there is a ID column which is dropped by default by this particular data sets. If you happen to download, then probably they may come as a kind of a separate column. But total, we'll see there will be 32 features. But the one features here that we have downloaded here is 30 features, and there is one label data, which is called the target variable. So here we can see radius one, texture one. Likewise, you will see all the 30 features that is being captured with respect to that particular tumor cells. And you can see these are all in decimal places. These are all decimal numbers, right? Now, that is what we call my features or feature variable, or probably my dimensions in the first. Now, there is a target variable, as I mentioned, whether it's a malignant or a benign. So here we have labeled information. M stands for malignant and B stands for benign. Now, if I also run this, this comes as, okay, these are the informations that comes up. I'll take a quick pause here so far people are comfortable. Okay, so now you can see is that this particular step is very optional. You might not need this, but sometimes while writing your research paper, you might be interested to call out in your bibliography sections or reference sections that from where what data has been collected, what's the source of the truth, and all those information. So it also provides those metadata information about the breast cancer. So this is absolutely where I'm not using it, but this is kind of a meta information about what are the other informations that I can learn about this particular data set. For example, this data set was last updated in the year 2023, November. It's close to some 2 years back that has been updated. And these are the creators. So those are some metadata informations, which is not so relevant to our use case, but maybe needed if you wanted to cite it in your research paper in the first place. It also talks about what kind of variables are we dealing about it. So here it says that there are around total 32 features or variables, but the X, Y variables, which is your target variables, if I deduct that, it will come around 31 features. But if I deduct the ID also, now that becomes 30 features. So here there are only 30 features are there. So here is your diagnostic, which is a target. So it talks about what is the role, what is the variable that is responsible, what am I should I be predicting. So if somebody who is a new guy and trying to get along with the machine learning space, so he should know that, okay, what should I predict in the first place? What is it? Y feature? Is it X feature? How should I classify, or how should I know what features should I be doing? So this gives you some kind of intuitions that exactly that this is your target variable and rest all will be your features. And ID is something that generally we drop it. That has got no role here. It also talks about, are there any missing values in the first place? So if there are any missing values, then probably you have to massage that data. So this kind of information, once it pops up, you will start be able to crafting like, okay, so this contain missing values. Okay, so should I be eliminating those missing values? How many of those missing values are available? And if I delete so many missing values, then will it impact my model in the first place? Because the data is already small. How can I replace the missing values with some values? Could I use average? Could I use median, mode? All those things will take a different track given the interest, in the interest of time. Not everything could be captured, but I'm just giving you a thought process that once we come across this kind of data, so that's where you start thinking through like what I should be doing in this case here. I'll take a pause here.
Any one of you are working parallelly, you can unmute yourself and you can come ahead. Like yesterday, if you want to share your screen also, Abhijit would be very helpful in clearing your doubts or anything.
Absolutely.
Data is there, coding is there, you can come ahead. Professors don't think that this is a healthcare data. It is not like that. XGBoost is a ML library. It can be utilized for HR analytics, marketing analysis. This is only an example from his perspective. Library is same for all predictive analysis. Okay, if not, you can go ahead first.
Sure. Now that we have the X features and Y target variables, I'm going into the exploratory data analysis. Now that I have extracted or fetched the data from the source, now I want to do some kind of analysis here. So if I have to do that, I have to make sure that I am not getting deviated with different kind of data set versions. What I meant is that if I analyze X separately and Y separately, given that Y has got only two types of variables, one is malignant and benign, it doesn't give more information. But once I merge them, join them with my X features, and then do analysis, it will give me kind of a distribution with respect to malignant and benign kind of features. So that's why this particular step is basically to combine these two X features and Y target variables as one single table or data frame. So if I may run this, it is able to join them. I also made sure that it's very straightforward that I made sure that uh, I actually lowercased all the column names. So this is straightforward. Sometimes we make very simple mistake. We are not able to refer to the right column name. So it's better best practices that we should all convert those camel casing or capital casing to lowercase. And as you can see, I'm able to join the X features and here the Y target variables, which is here in this case is diagnosis. Once I have this, I also try to understand whether the dimensions are correct. Yes. As I remember in the initial part of the discussion, this particular data set has got 569 records. And I know there are around 31 features. The 32 feature is the ID, which we have dropped it. 31 feature because we have introduced the diagnosis, the Y target variables. So 30 X features and Y diagnostic feature together they made around 30. So this kind of numbers helps you to make sure that the data is intact. And now we can go ahead with other analysis. If this number doesn't matches here, whatever analysis that you try to do, whatever modeling that you do further from this process may lead to some kind of erroneous results. And when we generally review our fellow data scientist work, we generally look at this kind of informations at first. Okay, whatever he has done is all correct in terms of data processing, massaging, and the way he has merged all the data, so that now we know that whatever data from here is good enough to do the ED analysis part of it. So the first EDA that we do is talk about like what are the different kind of Y variables are we talking about. So here this particular code snippet will help you to give me malignant and benign kind of a data set. So these are the two unique categories that's available with respect to your diagnosis Y target variables. If I wanted to also understand how does this plot looks like, I will slightly zoom out for now just to show you this. I'll zoom in again. This tells me that, okay, the diagnosis distribution. So there are 569 records, out of which 37 percentage close to are malignant, which is like dangerous, and benign is like, okay, these are not dangerous, 62.7%. What idea that gives us is that, okay, this class is not heavily imbalanced. This is kind of a decent, fairly balanced data set, though not 50-50. We generally don't expect 50-50 data sets also. Most of the time, we generally see it's quite highly imbalanced data set. That's the nature of every process that or the point of source of data that you collect in real-time environment. So this is very important for us because if we don't check for class imbalance, the model that's gonna trained get biased towards the most dominating class over here, just like this case. Here, benign is very dominating over the malignant class. If it is very, very imbalanced, like let's say 90% versus 10%, then whatever model that we are going to train is always will bias towards benign kind of data sets, which means that we have to do special treatment with your data set, which is like class imbalance problem. You might use more techniques or any other kind of sampling techniques to make sure that we bring it to fairly balanced. So can we talk about a use case where it comes fairly imbalanced? Is basically fraud analytics data sets. Because fraud analytics data sets, what happens if there are 1 million or 1 billion transactions, there could be good enough 1,000 or 10,000 transactions which might be fraudulent. And if you just see the ratio, it's coming somewhere in 99% versus 1% or less than 1% in some cases. So in that case, we need to see that now the data set is not 70-30 or 60-40 or 80-20. It is 99 versus 1%. Now, we need to understand that 1% is the business ask. That is where the business is losing out maybe millions of dollars and billions of dollars. If it is a kind of a Fortune 50 or Fortune 40 company like Walmart or target or less. So that 1% transactions, fraudulent transactions, that can cost them in millions of dollars. Now, those are some of the rarest cases, and that is exactly what the model has to be built on. Now, for that, as I said, this particular use case will not be able to cover up those kind of use case there itself, because some people might have to learn about the smart techniques to how to handle it. But there are other techniques also where we have to balance the class, because sometimes if we say 99%, we may have to do some statistical analysis on the 99% of the data. If they are fairly similar, we can definitely drop some of the 99% of the data, maybe try to making it balanced way. So we have to make something like stratified sampling where we can represent both the kind of classes together and in a very equal proportions, and making sure that we are not losing out enough information. Now, if it is a two-state problem, like this, the fraudulent, is fraud like yes or no, or a binary kind of a problem that we talk about, it's very straightforward. But the kind of use case that generally we deal with in industry, sometimes it goes around 5,000 different kind of classes. Now that becomes extreme multi-class kind of a problem. And there, what we try to understand is that, hey, boss, do you think we need to look for all the 5,000 classes? Are they super important to you? I mean, what is that particular class that impacts the business? So we kind of use of this Pareto principle, like 80-20 kind of principle, to see that if we have to see that out of 5,000 classes, is there any top 200 classes which represents or constitute of majority of the records? That is one where we have to focus on. We can simply ignore away some of the classes which might not be so relevant in terms of dollar value or business value in the first place. So those kind of steps is very important. And this kind of analysis is very important, that we should document that. We should have to produce this as an evidence to the product teams, saying that these are the symptoms that we are seeing with this data set. And that is the reason why we decided to drop off or chop off those remaining classes in the first place. And if the business come back saying that, hey, Abhijit, why did you, spare away those remaining 4,500 kind of classes? Almost you have dumped so many classes out of the picture. You just focus on these things. We can kind of provide them the hard evidence that this is where we are tying it to the business value, where we are tying it to the dollar value. Those remaining 4,500 classes were never in the picture, and they don't contribute so much, and they have been inactive for a really, really long time. So where you might do a lot of data analysis, be on Postgres, Oracle systems, or Snowflake systems, to understand when is the last time those highly rare occurring classes have appeared into our database. You might be surprised to see that some of them might not be occurring for the last 5 years. Then why are we even bothered about those 5,000 classes? They never came back in the last 6 months and 3 months. It's because there is a seasonality entering. Of course, we will not be able to cover all of the aspects, but I'm just throwing up those ideas that when you do kind of analysis and research, those things comes into the picture. While this is a kind of a day-in-day job for us, we know that this kind of data sets, this is how it looks like. So probably we know exactly what kind of algorithms to use in the first place. But sometimes when it is totally new area, a kind of a uncharted territory for us, we kind of, though aware of all the aspects, we do go through all the steps one by one and start documenting of it. So that's why it takes around 2-3 months for us to actually do an ED analysis before we jump into the model part of it. Because we feel that model is just model.fit. But if you have not crafted your feature engineering very well, so this is going to come back to hunt you, because you will not be able to defend your F1 score, precision, accuracy score part of it all. So with that, let me come back to the Jupyter Notebook. I just zoom in again, as I said. Hope this is visible. So now we are doing a label encoding part of it. What does that mean is that M and B is a alphabet. Machine learning algorithm don't understand those English language. We have to convert it to some kind of numeric numbers. Now, numeric numbers it has got cardinality issues where 0 is less than 1. It should not mean that way to the model. So 0 and 1 is just kind of a label information. That is what we call labeling or label encoding. So where we transform M to here in this case as 1 and Benning as 0 here in this case. You can feel free to choose any number, vice versa. So there's no problem as long as you understand and explain. So now, once we have converted that into label encoded part. So if I go to the diagnosis here column, I could see now the M has been translated or transformed or converted into 1 and B will be in zeros. I take a pause here. If there are any questions or people are still catching up.
Usually, faculty members will actually ask a question in a way where how they can link these predictive analytics into their academic research. That is how they would like to link. Usually, publications is one of the key performance indicator in all of them. So how this can be converted into a publication where they can access the data. So any questions will be there like that. You can explore a little bit if we can expect some questions on that area.
Sure.
Our participants, if you want to talk.
Sorry, your voice dropped. Can you repeat that for me? Okay, once it comes back, so probably. So I'll just continue forward here. So here what I am trying to do is that now that I have 30 features and I have labeled it, so these are all numericals, doesn't make any story to us. How can I build story? How can I explain this data in the first place? So in case if you are working on any of these open source data sets from any other data bank, could be COVID, could be anything, or it could be with respect to retail kind of data sets, where probably you have to do something kind of a logistic regressions or a binary classification problems. It's very important that once you have this data set, you probably have to understand the statistical side of this particular data set. You should be able to explain, interpret the results. So you could see that as there are 30 features, the common questions comes that do we really need to learn and understand all the 30 features? Maybe, may not be, depends on the use case. If you are able to understand, that's fine. But sometimes in real use cases, there used to be thousands of columns that comes into the pictures, and most of the times, about 90% or 70% of these columns doesn't make sense in the first place. But if they make sense, definitely, how do we know that those 70 columns or 30 columns make sense and contribute something to the model's performance or accuracy or classifications? So for that, we probably have to do statistical analysis on top of this particular data set. So some of them could be related to standardization normalizations. I'm pretty sure like some of you might be familiar with this part, but standardization and normalization, basically, if I have to put it in simple ways, that let's say what happens is in this particular table structure, if you're seeing that the area on one feature, max value is 2500 and the smoothness value is 0.1634. If I have to plot it in a kind of an XY axis, this particular area, X feature will be somewhere in 2500 label or probably mark, while this will be within 0.163. What happens, it's a very problem for a kind of a distance-based algorithms and may not be able to scale up because the unit of metrics for different columns are very different. So is there a possibility that I can transform them and bring it back under 0 to 1 kind of a scale so that I can now bring all the features into a kind of a spherical form of the representation of the data set? So that way what happens is that whatever algorithm that I'm going to use, it will not have impact due to scaling issues. So that is one of the reasons why we generally do the standardization operation. During this EDA process, we also try to see if there are any outliers. Is it a right choice to remove those outliers? How many outliers are there? So if you get those kind of data, for example, if you get kind of something COVID data, and it's a very rare cases, it's not falling as a part of an outlier out of 150 crore populations. Let's say if we are talking about India, um, do we have to drop that outlier in the first place? If it is in a very minuscule and if it doesn't impact your model accuracy, definitely we can do that. But if it is in a large chunk, then probably we have to do some kind of treatment with those outlier analysis. So that's why those things are super important if we have to put up in a graph, in a kind of a chart way, or probably statistical way to come up with C observation. So this is where we need to do about it. So I have put up some uh, uh, kind of cues or hints like why this is important, why this matters, and what we should be doing, what kind of plots that we should look for. These are some of the part, but not limited, because based on your complex use case, you might have to do a kind of a Google search also. I'll be honest with this, because sometimes you might not click with all the kind of algorithms that is very familiar about it. Sometimes you might see that cosine similarity is a suitable use case or suitable metrics to evaluate a model, but that might not be the case. And we have already seen in our case here in our industry here. So I have tried to document some of the aspects of it. So have a look at it. Maybe post this. You can Google out why this is important. What does it impact? Maybe if you want to play with other kind of data sets, this techniques, once you start applying it, you will get acquainted and familiar and confident about those techniques. So once you really get to work on a real use case in a, let's say, for a research purpose, based on the nature of the data set, you should be able to understand, okay, I will be using this particular approach or not. That kind of questions you can put it across.
Sir, I have a question. Am I
Yes.
audible? So you have
Yes, sir.
mentioned two terms here. One is standardization, one is normalization. I understand that there are two different techniques. You were trying to explain standardization by talking about two different scales, which you said. One was the wide range, one was very small range. So you wanted to bring everything in a range which can be put in a closed sphere, something like that. Did I get you right, sir?
Perfect. Perfect.
That was standardization.
Yes.
So then what is normalization?
So standardization is if you want to get a kind of a Gaussian distribution, like in case if you, I mean, both do the job very well, but then with standardizations, you can actually get the deviations and your mean under a kind of a control way, kind of a Gaussian distribution kind of way. So if you Google it out, you will get a formula where you can understand how that is very different. Your normalization is not definitely will not be a Gaussian distributions. So it depends on the kind of um, your use case, what you want to apply. Sometimes normalization works in some of the data sets very well. You don't have to do any kind of standardizations in the first place. So, but depending on the use case, and I tell you one thing, if let's say you have a machine learning algorithm, you try with standardization, and next time you try with the normalization also, it won't give you that much of significant responses if you are not using any kind of distancing algorithm. Because, for example, random forest, maybe scaling might not be so super important, while k-means clustering will be super important. And based on the distribution of the data, if Gaussian distribution makes sense here, you might want to do a standardization of the data set. So that's one way. So it doesn't have to be like necessarily that we have to use or only have to use standardizations and forget about normalizations. But yes, does that answer your question?
Yes, sir, thank you. I had another question. Now that we are trying to do some predictive analytics using an open access data on breast cancer, malignant and benign, and you have 30 attributes. So you're trying to narrate a story based on the historic data. Am I right, sir? So I think from the 30 variables, we will be able to identify the causating or the most causating factors which lead to malignancy, something like that.
True.
True. So I was just looking at how we will narrate and what would be the techniques that we will use. We are just entering the data. We did an EDA. So can we, as the session unfolds, will we get to know more on the predictive side, sir?
Can you repeat that last line?
As a
please?
session unfolds further, will we
Yes.
get more to know more on the predictive aspect of the data, sir?
Yes, with respect to this data set, but it is not limited. The reason why I'm saying that, I'm aware of a few more other approaches which works with other data set, but it didn't work out in this particular data set. But as in when we start going deeper into it, it will start talking about those histogram style of that. Okay, what does it mean? So it will try to help you to understand what does this data talks about.
Okay, sir. Thank you so much.
Thank you. Yeah, if there are any questions, feel free to stop me. And if you are already ahead of what we are trying to do here, feel free to proceed further. Because the EDA part is super important because applying algorithms is straightforward. Because there could be a question that, hey, how do I know that logistic regression is suitable for this use case over the random forest or over the decision tree or XGBoost? So generally what we do is that we kind of try with all the 5 different or 7 different or 10 different variants of the classification algorithm. And we try to see that which one is giving us the best results. It is not the case that logistic regression or probably random forest work really best in this particular data set. That means it is the de facto algorithm and it should work in every other kind of data set. May not be the case because it totally depends on the nature of the data distribution present inside the data sets. If it is able to capture those patterns, that means that algorithm fits there in that first case and may not be suitable for others. So that is where transfer learning might not be so super applicable, especially with the classification, classic machine learning problems, as you generally see with the advanced deep learning models or LLM-based models. Here I did, coming back to the Jupyter notebook, I just did a kind of a describe. So describe is a very straightforward. It tries to give me the count, mean, standard deviations, mean, and 50th percentile, 75th percentile max numbers across all the features. You could have it in your Jupyter notebook, but I'm just also scrolling here. You could see all this information with respect to diagnosis. Now, sometimes these numbers are in tabular format, may not make sense, but if you are able to understand some of them, so you can always interpret those data sets and can come up here itself. So you can say that these are something we have already identified about the imbalance part of the data sets. I generally categorized here, it's a kind of very subjective that I have categorized the best one to be the mean, the standard error as the median, I mean the fairly decent performing, and the worst features I have categorized as the worst or largest or ending in 3. So what this ending in 1, 2, 3 means is that if you see those variables, it's 1 that is ending with 3, 2. So I have categorized them into, you need not to do this particular part just for the sake of the discussions here in this session. So I have just tried to put it across so that you know that how I'm categorizing it here. So it talks about some of the insights that, okay, these are the mean features, why it is important, what are the implications on the malignancy. So malignant tumors are generally much larger than the benign ones, the large difference between the 75 percentile. So you can see that these are the features which talks about it. I will let you read this because it's something which I have also interpreted from the results. If there are any errors, feel free to let me know, and we can always make corrections about it also. But this is what the idea of what I'm trying to throw is that you put up a describe function on the data frame, and it will be straightforward giving you all those basic statistics or the descriptive statistics about the part. You can still interpret like what is happening or whether there are any correlations. But in case like you wanted to have a visual kind of a way of looking at it, no, this is still not giving me kind of information. If you want to demo or show it to your leaders or probably your seniors in your profession, so probably you might want to come up with a pictorial way of presenting it actually. So here is one such example where I'm further going into kind of a way of segregating between the malignant and the benign data sets here itself, and then trying to come up with the histogram style of way of coming at it. So I'll just zip this out a little bit. You can say that here the histograms, what it is trying to say that if there are very much of a lot of overlaps, you can say there is no clear demarcations with respect to the features. But whatever features that we have chosen here has got some clear demarcations, except for some of them, like smoothness one is not having clear demarcations because there is a lot of overlapping. So with these features, you cannot make out that whether by looking at just particular smoothness feature, is it malignant, is it benign? Because it's highly overlapping here. And let's say these are all skewed. If we just, for the time being, ignore this particular part, the majority of them is having an overlap with your benign part of it. So you can't clearly draw a line saying that anything beyond probably 20 is benign or anything below 20 is malignant, something like that, right? So you cannot make that story out here. So, but this kind of histogram is a quick and dirty way of looking at and easily see that, okay, are these features making sense in the first place? But this doesn't give you the clear picture that how important is this feature or what is the weightage of this particular feature in the entire analysis. It just gives you an intuition that just this particular feature has got overlapping features. So you can always use different kind of plots are also available there. So I'll let you go through that by yourself because I'll just try to I have documented all this information here for you to study this. I'll just quickly, I will show you the violin plot, other part of it, if you're saying. So you can always go and interpret these results over the histogram also. The reason why I'm saying that sometimes graphical way of interpreting the columns importance also helps you to make some decisions that why it is important in the first place. But how much it is important, that's a different thing altogether. But it gives you a quick impression that what is happening. So I have taken 10 features one at a time and started drawing the violin plot of it. Here I have just taken only first 10 features and then I have come the histogram. So maybe you can also use all the 20 or all the 30 features and see for the histograms, like how is it overlapping or not. And here it can give you some other impressions like whether what is the mean, what is the median about it. But you need to probably have to understand the concept of the box plot, the violin plot, the histogram plots, and all those informations about in the first place because you start interpreting. At first, it looks like some kind of vague diagram, but once you get acquainted with this, but you will get more familiar with this part. So likewise, last 10 features. Once you get this, I have left some space here to interpret these results and put up your theory, like what is happening with this particular part. But this is one of the key part to understand the feature importance with your open data sets. Like you got COVID data sets, there could be 10 columns or 100 columns, hypothetically, I'm just putting one example. Now, how do we know that all the top 100 columns are important, all the 10 columns are important? Sometimes this kind of visualizations helps you a lot. But then as I said in the beginning of the sessions that I have put up deliberately a different kind of algorithm here, which helps me to kind of eliminate those features which are not relevant for my algorithms with this particular use case. So one of this algorithm is called recursive feature elimination with cross validations. Maybe I'll try to break it down. As the word mentioned, recursive means that it is going to be a kind of looping way of eliminating the features of recursive feature elimination. What is cross validation means that it's another kind of a concept that you would like to Google it out, but just for the sake of keep it short also. Sometimes when you take the whole of the training data set, which I'll talk little down the line also. So once we have the data set, we generally split into training data set, test data set, and the validation data sets. Now, sometimes when we try to train the model on the training data sets, given that we have shuffled it multiple number of times before we start training the data, there are apparently possibility that the model might get biased because of the sequence of the events also. There is a possibility that model might learn the sequence, may learn the seasonality of it sometimes in some of the data sets. So generally what we do is that we split the training data set into multiple small components. Let's say we say that uh, 100 records training data set is split into 5. So that means each split contains 20 records. Now what happens? Model runs on 4 of the blocks or 4 of the splits and test it on the remaining 20 records. And likewise, it will do in a recursive way, in a kind of an alternating way, kind of a round robin way for every other blocks. And then it decides, okay, I'll try to take an average of 5 different such experiment, and then I can decide whether how the model is performing, which will definitely is the part there in the code snippet also. So here in this recursive feature elimination, what it basically does is that it tries to recursively look into all the 30 features, predict, and then it decides, okay, there are 30 features. Now I can eliminate the bottom 5 non-performing features from the experiment. So now I'll have 25 features. Now then again, it will run this experiment again using the recursive feature elimination kind of over on top of random forest. Then it will try to eliminate the last non-performing 5 features again. So likewise, it keeps on doing till it reaches those first top, could be 10, could be 15, could be 18, depends. So generally there is based on the variance. So it decides how many features are very important for this particular kind of exercise there, or probably this particular algorithm, or with respect to this particular data set. So whatever analysis that we have done so far with the EDA part of it, if I just roll up, let's hypothetically accidentally decided some random features, and for some reason you're trying with random forest or any kind of algorithm, and it is still not performing really well. You might want to see that, can I use this particular technique which is available in scikit-learn package, recursive feature elimination, and can I see that what are the top features that is so important over here? So that's where this particular algorithm comes into the picture. Yes, this is the training data set that I was talking about. Here I have split in 70-30. You can feel free to split into 80-20, but here I have just taken it as 70-30 kind of split. I've used a random key state key here, 42, so that every time I split, it will generate me the same kind of records here. So I run this. I also was able to create the training dataset and test dataset, and I have to drop some of the type features variables from the X. And once I do this, here I'm using this, as I said, it will split into 5 splits here. So here is the cross validation 5 splits, and I'm saying that accuracy is important. You can also see that I'm able to use all of the processes of your system. So you can also see and experiment like what are those features that make sense in the first place. So once I trigger this, so what happens is that we can see that it will be little computationally intensive, but what would happen is that at the end of the day, given that I have run it multiple times, so I could see that there are 15 important features that is so relevant, and it slightly contradict with what we have analyzed something back. So this actually kind of a checkpoint for us that whether we are capturing all the right features relevant for our use case here. So this will take some time here. In the meanwhile, any questions for me? All right, so this has actually run completely. So what it basically says that, hey, there are 15 features which are very optimal for this particular part. And what it also says that these are the features which are very important. If you remember in the starting of the discussions also, I said that anything that ends with 3 are the worst features. It happens as a human being. I also make mistake that probably I've interpreted in a wrong way. Those features are which I categorize into as worst features are somehow very important as being defined by the recursive feature. So basically you can see that it started with very less feature and it's keep on adding in a kind of incremental way. What I explained in a kind of a decremental way, or the bottom up approach or the top down approach, but it can here in this case, it tries to come with the cross validation score, and here is the number of features selected at one point of time. So what it basically says, the cross-validation score accuracy was almost more than 96% when it selected with 15 features. But post that, it dropped. So that means this could be, think of like a peak point. So here we decided that this is the 15 features we to cover. Now, likewise, if I just say that if I use these 15 features for my machine learning model, these are we'll come back to this particular part, but I'm going back to here the logistic regressions. I selected the best features. Okay, I selected the best features. I used the logistic regressions, and it could give me 90% accuracy. I can read on this again, but I have to run those previous functions beforehand. But what it meant is that with the vanilla model, with this best features that I tag them is giving me 90%. But then when I start using those selected features or the selected features over here, the model boosted a little better, 95%. So what it meant is that somewhere my analysis with these popular tagging features didn't work well. So I used recursive feature elimination to understand. I think I missed to account for those features, but those features are super important. And it is improving my accuracy by from 90% to 95%. So I'll come back here again. I'll run it also. I have tried to document and put a lot of explanation in the code snippet. Whenever you have time, feel free to run this and experiment this as per your convenient time. I think this is a duplicate. I can drop this. Yes. So this is again the selected features. So initially the model was giving me 95%, and then with cross-validation score, it comes close to 96%. So have a look at this report also, that how it actually performs. Okay, so question is, what is the minimum variables required for the training? So that was the first question. So should I use all the 30 features or all the 30 variables for my training? But then will I end up into curse of dimensionality problem? Too much of features will also dilute my prediction also. Okay, I did a recursive feature elimination, and I was able to eliminate 15 features, and now I can use 15 features. In real time use cases, there could be thousands of features, and let's say the recursive feature elimination came up with some 500 features, hypothetically, I'm putting up a case scenario here. Now, does that mean that I should be taking all the 500 features? Now, that's a humongous features to begin with. So generally what we also do is a kind of a dimensionality reduction technique also. Can I actually transform those 500 features into, let's say, 30 features or 20 features in the first place? Now, how do I decide that? It's basically on the variance on different axes with respect to the PCA technique. So generally also we do use t-SNE kind of an algorithm on a bigger data sets, on a larger number of classes and variables, to see that what variables is super important in the first place. So there is no rule of thumb to say that I should be using 2 features over 20 features, because as long as those features explains the characteristic of your data or record, here in this case the tumor, I think that should be the number that you should be looking for. Here in this case, out of 30 features, because the algorithm was able to pick up those 15 features, I think I'll settle with this 15 features. Now, if I do more drill down analysis, maybe 15 feature is too much, Abhijit. Can we reduce it to less features, because that will be computationally less intensive and it will be faster. The model should be able to predict faster. I should be able to host in the production environment, and should be helping with the low latency part of it. Then in that case, I probably might want to push it to principal component analysis, PCA technique, a dimensional reduction technique. There is other techniques are also there for advanced cases. But if I do that, is it going to help me out? So that's where those questions is something that comes up. So if you ask me, are we asking all the right questions? I think that will eventually come up with more you play with different kind of data sets, more acquaintance is needed with different kind of data sets. And while I was starting during initial phase of my career, I used to ask a lot of questions. Okay, what if this case? What if that case? And how do I learn about some of those questions? Sometimes I hear to those product analytics or data analytics questions in the meetings to understand what is the business ask in the first place. So that's also helped me at the same time when we also discuss among our fellow data scientists, we get to know that why this features is going to be super important. Sometimes we also transform 2-3 features into one single feature. For example, the BMI. So we need weight, age, height, and gender to understand whether the person is obese or moderate or medium or the other scale. If can convert into a kind of a BMI index also with the formula, we can still be able to predict whether the person is obese or not. But then once we transformed some of the columns or features into another columns, it has to be backed and justified with business evidence or probably real-time evidence that why in the first place we have converted those columns or features in and transformed into a third features. So those kind of questions can also come into the picture. So I'm being like putting up like a lot of thoughtful process here that what actually goes while building it, this thing.
Okay, I think we can have any question and answers. We have explored very well with all data visualization. I think it's the real time one.
Yes. So you can go ahead and request to other folks also. You can go ahead and try with other kind of algorithms. Here I have tried putting the logistic regressions. I have also put up the code snippet for decision tree classifiers and for random forest. You might want to understand what's the difference between random forest and decision tree classifier and why can I use other algorithms. You're always open to use this. I have already set up some of the code snippets, so you may have to just call the function and probably it should be able to generate function classification model and should be able to do that. And if it is not the case, you want to come up with your own custom function also, that's also welcome. You can always put it across. But yes, once you get the results, you might want to put it up in kind of this kind of graphs and confusion metrics so that it will help you to understand what is happening with the model. How do we justify the use of PCA to business team? There could be there is one scenario which I could remember is that when the business doesn't want you to explain the what features are important for predictions. They just wanted to understand the binary output, yes or no. In that case, I can use PCA. For example, I'll tell you, in fraud analytics kind of data set, generally the business comes and asks me the questions that, okay, Abhijit, tell me, we have around hundreds of features. Tell me what features were you able to capture this significant case of fraudulent case here in this case. So in that case, I have no, irrespective whether my model is able to capture whether given transaction is a fraudulent transaction or a non-fraudulent transaction, the business might want me to answer this question that I'm interested to know what feature were responsible for capturing this information. Why they ask is because they probably would like to go back to the engineering team and ask them to increase their validation check on those parameters, on those features. They wanted to bring in more scrutinization in those columns over other columns, and they want to become more vigilant. But in case like they wanted to understand something like which is less life-threatening, such as in this breast cancer, this is very life-threatening, so it's very important. Let's say we talk about the retail case data set. We wanted to understand whether the customer is going to buy this product or not, given that he has visited these pages. Now, this is not life-threatening. There is no fraudulent transactions. It's just that to understand the purchase pattern, behavior pattern of the customer. So in that case, the customer is really not interested, or the business is really not interested to say that what features are very relevant. I just wanted to know whether my customer is going to buy this product or not. So in that case, we go ahead with the PCA kind of way of doing it. But yes, we probably have to take this to business, saying that, hey, product, we are going to apply this kind of dimensionality reduction technique. Here, this is going to help me to improve my accuracy from so and so to so. But I will not be able to explain the model why it did in the first place, because the model will become a black box for me. Because with feature importance, as in the case of the random forest, I could able to trace back what features were very important for me. But after converting into principal kind of component analysis, it will not have that case. Hope that answers your question, Chandra. Any other questions for me?
Sir, I have a question.
Yes.
I'm just giving you a scenario. Can you just suggest if predictive analytics is possible, and what is the approach you will suggest? See, can we get employability data on the public domain and identify based on the data set what are the attributes which could lead to future employability of a candidate passing out from a college, say any program or engineering or PG program he pursues. What are the attributes? Can this be a study? Can predictive analytics be used here? Can we identify
Yes.
attributes? So
Yes.
what is the approach you will suggest? Means
So
you were talking about random forest regression. So what is the method you think would best suit this kind of predictive analysis?
yes. So if I were in your shoes and if I have to take this project, so I will be least worried about the algorithm part of it, to be very honest, because maybe I might be doing this for so long, so I might be very acquainted with what algorithms is this. But then I'm not writing the algorithm from scratch. I'm using the packages, scikit-learn packages. So it's at my disposal to use or invoke any kind of algorithms or machine learning algorithms in the first place. What I would be really interested, and I definitely encourage all my juniors that you bring in all the data from all the different data sources. Now, I want you to combine them into one single table. And then let's do a kind of a feature importance or feature selection or feature engineering analysis or statistical analysis on top of it. So the data that you spoke about, like given this course, or given the he passed out from this colleges, or with this particular percentage, whether this person will get future employability or not. Do we have the label data? What I meant by label data is that, let's say you have 100 records and you have the ground truth, the ground check data that out of 100 folks, 50 of them have got very high score, maybe 90% plus, hypothetically, and they have done so and so on courses, and they got employed into so and so a company. So you have that ground truth data. Yes, they have been employed. And there will be some people who may have backs in the engineering colleges and they don't have all the necessary information. So with respect to course and all, so they didn't get the employability because they were ruled out because they didn't just meet the eligibility criteria of the interview exams, that's there, or the placement exam. So if you could collect all those informations, if you are able to craft that story with respect to your data, I think that is where you can start using different kind of algorithms. That will be straightforward. But your first job would be to do the EDA part, craft the data into a kind of a story, stitching a story there. So does that make sense?
Okay.
Yes, sir, I understand. We're talking about the labeled data. How about if the data is not labeled, it is an open data then?
So in that case, probably you might want to use unsupervised algorithm. So it could be like clustering algorithms that you would like to use it here itself. So clustering algorithms could be k-means, could be DB scan algorithms, because you don't have the label data, but you should be able to feature out all those important students who had all those courses, the scope of getting a job also better through the clustering level algorithm. So you may not use classification. Once you have the clustering algorithm, then with that, you can label those cluster as 1, 2, 3. That itself has become the 1, 2 as a label. And probably you have to profile those cluster informations And then you can parallelly build a random forest on top of it or XGBoost on top of it if you do not have the label data, but you have some informations. You might want to go to clustering algorithm.
Thank you, sir. Thank you for the input.
You're welcome. Any other question?
Thank you, Abhijit. Thank you very much for explaining very technical.
Thank you so much.
Thank you,
Dr.
Abhijit.
Arun.
Thank you for the thoughtful and insightful session. And always, just like always, you're so patient to address the queries also. So thank you for that. So we have our next speaker also joined us. So Abhijit, I'll connect with you later. Thank you.
Sure, sure. Thank you. Thank you, everyone, for your patience.
Sure, Abhijit.
Good evening, sir. Good evening, Raja, sir.
Good evening, ma'am. Can you hear me?
Yeah, you're audible, sir. So dear participants, we have our next speaker joined with us. So it's my privilege to introduce our distinguished speaker, Mr. Raja Basu, a seasoned leader in financial services, generative AI, and technology-driven business transformation, and currently a doctor scholar at XLRI Jamshedpur. So Mr. Basu brings with him over 18 years of extensive experience in defining and implementing technology-led transformations for clients across global banking and financial markets. So his expertise lies in automation, artificial intelligence, and their applications in climate and sustainability, coupled with a deeper understanding of value-driven advisory practices that strengthen client relationship and deliver measurable business outcomes. So throughout his career, Mr. Basu has successfully led numerous large-scale transformation programs involving complex applications for clients across United States, Canada, Europe, Singapore, and India. So his domain expertise spans security trading and settlement, custody corporate operations, and stocks, exchanges, internet and mobile banking, and wealth management. So in addition to his professional accomplishments, Mr. Basu is deeply committed to mentorship and academic collaboration. He actively contributes as an industry project mentor, industry advisory board member, and professional mentor at prestigious institutions such as University of Warwick, University of Bristol, University of Portsmouth, XLRI, and IEEE. So we are truly delighted to have him with us today to share his invaluable insights on technology-driven transformations, AI in financial services, and strategic innovation in the banking and finance industry. So please join me in extending a warm and hearty welcome to Mr. Raja Basu.
Hearty
So
welcome,
over to
sir.
you, sir.
Welcome, Mr. Raja Basu.
Hello. Hi. Thank you so much. Can you hear me?
Yeah, sir, you're audible. You're good to go.
We can hear.
Okay, great. Thank you. So just give me 2 minutes. I'll just.
Sure, sir.
Thank you so much, Professor Dr. Anu, and for providing such a kind introduction of mine. And really, I am grateful that I got a chance to talk to you over a business case, and hope all the participants, you will enjoy this. So probably what I can do first, that I'll go through the business case which we thought of, and then we'll pause and have some break, and we can connect on. If you have any specific questions regarding that, we can address those. So let me ask you, are you able to see my screen?
Not yet, sir.
1 minute. Are you able to see my screen?
Yeah, sir. Now it's showing like you have started screen sharing.
Yeah. Is it
Yeah,
okay?
we are able to see your screen now, sir.
Okay. Okay. So the structure of the presentation is that we'll start with some learning objectives, and then I'll give a brief introduction about the case background and what is the business problem, and then a brief introduction about generative AI, how, and most importantly, the consulting approach. Generally, when we take the client for our engagement and how the approach is and all about that, we'll touch upon, and then discussion questions and key takeaways. So I'll start with the learning objectives. So first, we'll try to understand the regulatory, the regulatory reporting challenge in retail banking. So this case is a hypothetical. I mean, it's not a real example, right? You know, where we have mentioned about one Claviant bank, which is basically not existing, but the type of problem and the business challenges. This is typically replicating that existing challenges what the banks worldwide they're facing, right? So first we'll understand the regulatory reporting challenges in retail banking, identify how generative AI can enhance compliance related stuff, and then applying consulting frameworks, problem discovery to pilot, and then appreciating the role of collaboration and stakeholder alignment, and finally how a design a proof of concept work and identify the relevant KPIs. So some background of Clavian Bank. This is a North American bank, and this bank is a retail bank, has a wider client base across geos, and this bank is currently facing stringent regulatory mandates, because most of the cases we see that, you know, AML, anti-money laundering, Dodd-Frank, these are the BSA, these are the challenges, typical, the, you know, the regulatory requirements that bank need to go through. And second is that banks, generally the large banks, they work like individual silos. They have different business units, and each business units are like individual organization. So when there is a requirement of reporting data or reporting in general comes for regulatory or any other internal issues also, generally they face a lot of challenges, because they need to collaborate, they need to coordinate with multiple business units together, and accordingly they have to collect data and they have to report it. So these silos, the working style actually creates a lot of problems for the banks. Now for this particular bank, the CIO is Jeff Norman, and he understands that GenAI is really, really powerful, but he's not very sure about, you know, how to address the GenAI, the current problem with the help of GenAI. But he's basically a supporter of GenAI kind of engagement. And we have Levy Consulting Group. So they are basically the consulting firms. Typically how it works, like in our existing setup also, big consulting companies, they work for clients and all. So here also we have a Plavik Consulting Group. They are a consulting major, consulting giant, and they work with big banks and financial market companies across the globe. And this is led by Indira Deshpande, basically an Indian, and an Indian and an alumni of IIM Ahmedabad. So it's kind of, you know, something is fabricated, but still giving some flavor to actual real case how it works. Then regulatory landscape snapshot is what are the key retail key governing frameworks that the banks actually they go through. So we have Dodd-Frank Act, which is typically like transparency and anti-speculation. So when we are talking about client, when we are talking about customers, so we always need to show that, you know, everything is transparent, there is nothing hidden. Then we have CFPB, which is customer protection and lending disclosure. So banks, they are into lending business. So whenever the banks do any sort of investment, so they need to show that where their actual funds are, they are actually investing. Then AML, KYC, BSA, these are anti-money laundering, just to take care of that there is no fraudulent transactions and there is no chances or like, you know, anyone is trying to do something which is unethical. Then TILA and TISA is consumer clarity specific thing, again, which is talking about, or it takes care of the consumers are safely guarded. And then we have our old Basel norms 1 to 4, which is for capital adequacy and global standards. So typically, like, banks need to showcase that they are two things which are very important. One is that they are adequately cash reached, which are like there are very less chances the bank will go bankrupt in case there are some challenges. So periodically they have to comply with these capital adequacy requirements to central bank. Same thing happens in India also. We have Reserve Bank of India, and we all know that the Reserve Bank of India is working as a watchdog for most of the banks in India. Same thing happens for banks across the globe also. These are the major kind of health or hygiene checks that the central bank does for all the banks working for anything related to clients. Now, the business problem, as we started saying that first problem, the major problem is that the data is dispersed across silos, because the banks have multiple business units, and these business units, they are related. It is more like they have a chain of working together, but somehow they work typically like individual organizations, and they keep the data with themselves. So when there is a requirement need for generic reporting for any compliance related issues, there is always a challenge, right? Because it usually takes a lot of time, the data is not correct, the data is not updated, or a lot of things are there in communication. This thing happens. Then manual intervention, many cases this has happened. Some of this data they kept in Excel format or somewhere in their local machines, so everything is not automated, and sometimes there are a lot of inconsistencies also. The same, all these problems are also faced by this particular bank, Clavian Bank. Difficulty in mapping data and dynamic regulation. So you have business unit A and business unit C. Now you are getting data from both the business units. Now there is an 11th hour, and you are facing a challenge because you are not very sure about is data A is actually related to data C, because they have given the data individually, and these are discrete systems. So this is another challenge that banks mostly are facing. Risk of penalties and reputational damage. So if there is always a stipulated time frame that you have to comply, and you have to report to them within that time frame. Now, in case you are not able to provide the data within that time frame, then there are chances of penalties, and of course there is reputational damage probability. Now, pain points, locating correct data for each report, as there is no single source of truth. As we know that there are a lot of multiple data sources, and they are coming up with a lot of individual data reports. Now, mapping new regulatory requirements in real time. Now, this regulatory work is also dynamic. This world is dynamic. They keep on changing. Now, if they change, let's say 6 months down the line, or last time when they reported the same thing 6 months back, there some of the fields where this is a real problem, some of the fields were different, and now what they are asking for when they are opening that, they are seeing that some of the fields they have changes, or some regulatory requirement they have introduced as something which is completely new. And for that, there is no collaboration between the silos of the organization. Now, last minute, they are facing a real challenge to understand that how the data can be formatted, masked, or whatever way, so that they can actually comply with the new regulatory requirement. Now, stakeholders, we are just giving a brief introduction about the stakeholders. Jeff Norman, as we say, that it is like he is basically CIO, and he drive mostly AI-based compliance reforms. Then we have David Richardson, he is CEO. He is basically the last word for governance and executive alignment. So everything should go through his approval. Then we have VP Retail Banking, Rudra Basu. So he's basically domain and data ownership. He's somebody who understands the business very well, and retail banking business very well. And he is the owner for all domain, industry, data specific thing. So he's basically the custodian. Then consulting partner Indira Deshpande, as we said, like, he is basically the strategic oversight person, so who will probably help the client to understand what the problem and how that can be solved. She has her team members, AI architects, Srini and Srimanta. So they have previous experience of working in GenAI and probably in GenAI implementation as well. Now, I'll not get into details, but a brief thing, right, about what is the origin, like AI, artificial intelligence. We have machine learning, then deep learning, and GenAI. So GenAI basically the new introduction, right? And we have now agentic AI also. Most of the time, that what we see nowadays, uh, uh, clients across the world, they are just very curious and interested to understand that what value agentic AI can bring to them. So the core components here, I think, I mean, it's very basic: encoders, decoders. So encoders, and then transformers, and then foundation model. So encoders, they actually receives that typically, like, whatever business context, languages, etc. And decoders, they transform them. And typically, like, BART is an encoder, and decoder, GPT is a decoder. And we have transformer, which actually helps to create that sequential sentences and all, like T5 is a transformer. Then some concept of RAG, which is retrieval augmented generation. Why RAG is required? We know that generative AI is all about data. Now, this data is a big question, is that whether the data is authentic or not, whether what is the source of the data, is it something which is useful at all? So for that, we need to have some sort of, and when we are doing some reporting, it's very important that we should have the authenticity. So for that retrieval, that RAG is something which is very useful. And what a RAG actually does, they document, they actually provides the grounding principle, which is a, like, they split the documents into chunks. It's an embedded technology and stored into vector DB. So we have Chroma DB, typical an example that how the vector DB, what type of vector DB generally are used. Then user query converted into, as we said, like encoder, decoder, and transformer, and then embedding, and model retrieves relevant. Now, once model understand that in a mathematical form, and then model reaches out to the grounding, the source, right, truth, that those are basically the organizational data. Because most of the time the questions are asked related to specific to the systems, or specific to the information which are kept within the organization itself. So that's why that data sources mostly are the within the organization. This is not something outside the organization. And LangChain is a framework, and that, after that, the contextual, it actually provides that authenticity and contextual evidence that, okay, the data which is used is actually authentic and right in the context. And now, what is some of the advantages and limitations that it may have? Advantages is that, as we understand, it is very fast, right? Faster data retrieval process, and handles both structured and unstructured data, and reduces manual effort. 70% it is now. Somebody can ask the question, why 70%? Why not 71 or 69 or 68? So this is basically a thumb rule. Most of the cases we have seen that it is approximately hovering in that range only. And then enhances audit traceability. And limitations wise, it is dependent on knowledge based quality. And sometimes what happens, it is dependent, right? So if your knowledge base is not proper, comprehensive, not exhaustive, then obviously it cannot do anything, because it is somehow linked to that particular knowledge base. Then limited reasoning for multi-step logic. If it is very complex, then probably there are some limitations, and may propagate. It is a common phenomena, bias and hallucination, which is very common. So this happens to everywhere. I mean, every GPT model, and requires human validation. That is also something which is very important. So most of you are from research background. You know that nowadays people are also taking help from GenAI, but always say that you need to validate your data before you actually putting right there in your thesis proposal or in your research paper. So that is same thing applies here also. Wherever people from the organization, they are using anything related specific to GenAI, they need to also validate. Some sort of validation is required, right? Whether the data is still correct, because when you're talking about something like regulatory reporting, it's very, very authentic. and what data you are providing, it's very, very important, right? From whatever perspective, if it is a penalty perspective or reputational damage perspective, it is very important. So that's why the organization cannot entirely depend on GNI or RAG, right? So they need to have that human eyes on the top of that. Now, consulting approach, typically we are talking about Plavik consulting engagement model. Typically how the consulting model works, this is just a replica of that. So whenever we go to any organization, we try to understand what is the problem statement. So problem statement we understand basically from two approach. One is inside out approach and second one is outside in approach. So inside out approach is something like, understanding, working with the client with some design thinking workshop and all, which we will discuss also, that how we can ideate. It is there, right? Defining, empathizing, defining, ideating, prototyping, testing. So understanding from the client himself what are the pain points, what are bothering them, and then coming up with a problem statement. That is inside out. Outside in is something which you are doing a secondary research before you actually getting into this engagement. You are trying to understand what is general landscape, like retail banking. What, let's say this Clavian bank has some 5-6 banks who are the competitors. Now you are understanding also from the competitor landscape that what are the challenges the competitors are facing. So you have a very solid secondary research done, and then you are trying to understand the internal bank model, internal bank framework, and then trying to relate that whether this is in sync with the external models or something like, is there is any disconnect, or this will help you to get kind of a very good understanding about the overall health of the organization and whether they are basically working in right fashion where they are supposed to be. So this is something like a very comprehensive kind of approach. Generally, most of the consulting firms, they do before they actually identify the root cause, or basically they identify the pain point. Then what happens, high level, they do some sort of process mining. We have a lot of tools which you can do, like Celonis is a very, very good example of process mining. So which is something like understanding the process. So an existing process, even if you are doing an automation, trying to do something, but you need to understand whether that existing process is a good candidate process for automation or not. If the process is a good process, meaning productive process, not a redundant process, then you can actually think about that whether this process is actually good process, but now I can make it very good process. How we can do that? I can actually make it a candidate automation process, and then I can think about all the different layers of automation which we are talking about, right? But if the process itself is redundant process, then there is no point. It's a bad process. There is no point actually to improve that process. So one is that you can actually scrap that process or try to understand that if there is any other different options that you can actually help you to get there. Now, process mining is basically a technique which helps you to understand that entire process. It's more like an X-ray. So whenever you have a problem, like you have a bone fracture or something like that, you go to a doctor. Doctor says that you get an X-ray done. So same thing happens. A process mining is basically an X-ray of the entire process, and through that lens you understand, okay, there are cloggings, there are something like the external triggers, there are something like extra time taken. So probably these things I can actually redesign, and accordingly I can make the process efficient process. And then hypothesizing the digital intervention. So typically this is more like, most of you are researchers, so you understand that we also do similar thing, right? In research, we generally come up with a hypothesis based on the SLR, structured literature review, and then with the data, we try to validate those hypotheses. Same thing happens here also. You come up with some baseline hypothesis, and then you do your consulting engagement and try to see that your results are actually validating the hypothesis that you actually thought of. So here hypothesis is something like your initial diagnosis of the problem statement. I'll give an example. Let's say some client is just saying that their customer base is gradually decreasing. So here in this case, you can come up with your first initial high level understanding of that that inside out, outside in approach, and you understand that probably there is something like a active CRM system is missing, but that is basically a hypothesis. You are not very sure that you are going ahead with that initial hypothesis. CRM system is basically the culprit here. Because of that, probably the bank is not able to build the connection with its customer. But now you have to do a real consulting to get this inside information or whatever data you can collect and put it back right there to check that your initial hypothesis is correct or not. Sometimes it may so happen that it is not actually validating, then you have to change your hypothesis. So it's more like an iteration process. So you have to keep on doing till the time you get actual problem statement. Now, once you get that actual problem statement, so there are a lot of design thinking workshops in between. You have to do prototyping, testing. Here, the testing thing that which you are talking about, this test is helping you to validate your hypothesis. And there are different agile sprint planning also. So we think of some MVPs, minimum viable products, and we plan it. I'll pause here. If I'm saying something which is probably, something where you think that, I probably need to explain something more in detail, please let me know. I'll pause. If you have any question, you can ask also. Any question, anybody? Professor Anu, madam, is it okay my speed or I should slow down?
It's fine only, sir. Please continue, sir. Maybe in the end, we'll open for Q&A session.
Okay, sure. So now, so you understand that we have different prototyping and testing and validating the hypothesis, and then we generally come up with this. There is a feedback loop. That's why I was talking about it is basically iterative process. And finally, when you understand that what is your problem statement, your pain points, then actually you have to come up with the benefit realization and scale up plan. So what is benefit realization? You understand, okay, there are 4-5 major issues, major challenges which are bothering, and for which that customer base is declining. So here in this case, for which the regulatory reporting is not done in time. So these are 4-5 cases and 4 or 5 issues or 4 or 5 problem statements or 4 or 5 identified issues. Now we have to come up with something like that, how to address those in terms of technology enablement, whether. So when you're talking about that addressing those issues, there are two things which are also very important, that what is the cost factor associated with that, and then what is the timeline. So you have 3 categories generally, which are long term, short term, and medium term. If it is something short term, I'm selling it to clients, so I need to say that probably these are the low hanging fruits. If you are investing a lesser amount of dollar values and you can get it in a very faster within 3 to 6 months of time frame, and you can get it actually implemented, and you can start the benefits also, return on investment faster, and then probably you can go for the medium plan, which are typically like 6 to 12 months or 18 months. So those are mid level, and then which are very long term, which are something like 4-5 years, so which are typically finally. But you have to understand that whenever consulting companies, they always work like a trusted advisor. So it is more like first, helping the client to understand that we are not here for selling, we are here to solve the problem of the client, and then probably we have to build that relationship, that trusting relationship with the client, and then we can take it forward. And then we are talking about that like scale up plan. So this is benefit realization, which I was talking about. And scale up plan is something like in long term, generally all the client, they generally try to build a center of excellence so that they can manage most of the small issues or something like which they can manage themselves, their in-house team. So center of excellence is something which typically the consulting companies, they work with the client, and they help them to build that within the organization. Now, proof of concept plan. So here in this case, Claviant Bank, for Claviant Bank case, they are planning, the consulting company, they are saying that this proof of concept is something like to validate GenAI capability for regulatory report generation. So what they generally do, pilot is basically you have a massive work, right, in area which is something like maybe 14 towers are there which will be impacted. But for your pilot study, you have to do a very smaller piece of work, maybe 1 or 2% of actual, or maybe 5% of actual work, right? And you have to prototype it and showcase, that two things, couple of things which are very important. First is that how this will work, and what is the, so to build the confidence of the client, right? That, okay, this is how we are going to help you, and the results which will come out, and these results are correct results. So that is number one. Number two, you yourself also trying to understand that what I'm thinking is actually also proper, appropriate, my diagnosis, right? So that's where these things actually work. So you need some sample retail banking data dummy set, which you get basically from the banks. Also request them and they provide that data. And then here in this case also, the Plavia, they actually get those data right from the bank, and then they RAG pipeline with ChromaDB they used, and time frame they took that 4 weeks of time, and outcome they said some sort of KPI, right? You know, that it is 70% reduction in reporting time. Then I think they will think that it is something successful. And sponsor for this case, the entire pilot generally sponsored initially by the consulting company itself, and the Plavia consulting company is sponsoring this thing. So benefit realization, efficiency, they are saying that, you know, 70% time saving, as I said, right? You know, auto data mapping, the feature should be there. Accuracy, fewer human errors, 90% of compliance reliability. That's what they are saying. Some of the KPIs, agility, faster adaptation, and strategic improved brand credibility. So these are something. Last one is probably something which is not measurable immediately, but other than these initial first three are something which they are looking for. But this is something in long term, if they are looking for. Obviously number 4 is something which is a improved brand credibility, which is something also very important. Okay, I'll pause here. These are the discussion questions. Onu madam, you just want to add something here, or?
Sir, we will just start with the discussion question. Then we have few hands-on exercises also.
Okay.
So participants, there are few discussion questions from Raja sir. So we request all the participants to kindly engage.
So first question, that what are the current system challenges? We discussed high level, but again, something which we can discuss, and how can GenAI address these challenges? Second question. Third is that what are the risks and limitations of using GenAI? And fourth is how can stakeholder alignment be achieved for success?
Maybe one of you can unmute yourself and start talking regarding these questions.
Am I audible, ma'am?
Yeah, you're audible.
Yes, yes, you're audible.
Yes. What are the current system challenges? I have to discuss the challenges in terms of the use of GenAI. Am I right, sir?
No, in terms of regulatory reporting.
Regulatory
Because
reporting.
GenAI is a solution that they are proposing.
Yes.
But right now, the current challenge is the regulatory reporting issue, that fragmented data, time, brand value, etc.
Okay. So the challenge is like how we can do all these things with the responsibility and with values, human values. That can
No,
be the system challenge.
no, the current system challenge is they are facing challenges to comply with the reporting schedule. Sometimes they are delaying it because the data, the bank work in a fragmented way in silos, and because of this, sometimes they actually get delayed because the data takes a lot of time to actually collect together. And sometimes the data veracity is something which is a big issue. They are not very sure about the data authenticity. And third thing is that some of the data are also maintained in a manual form, right? So they are not automated. So data syncing is a big challenge. Sometimes data duplication, sometimes there are data authenticity problem, Sometimes mapping is an issue. So all the issues currently the bank is facing is related to two things. One is that reporting, and second is that if there is any challenges which are like delay in reporting or wrong or unethical reporting, then there are two things which will be impacted. One is their penalty, they are worried about the penalty, and second one is about the brand image, something about the brand value, the reputational damage. Have I
Okay,
answered
sir,
your
I got
question,
it.
madam?
Yes, I got it. Sir, in this another question, how can Gen AI address these challenges? So, is it so that what all things you have told, that the fragmented data and the validation problems, so all that challenges is addressed by Gen AI. So, Gen AI is able to create the data out of the existing data. Maybe it is in a normalized or formatted form, and earlier it is in a raw data. Is it like that?
No, here it is a business case which is like it is a business case where a consulting firm is engaged and the consulting firm is proposing that they can use GenAI technology to address these challenges. Now, how these challenges will be addressed, that they have not yet disclosed. So in the real case, what they have done, that they are proposing that we will come up with a pilot study and there will showcase you that how this thing can be challenged. And if you remember that I mentioned about two architects, Srini and another guy, so they are actually they have experience of working with similar client, and they know how these things can be taken care of with the help of GenAI. So this is an open area where we can discuss, but the consulting company has not yet come up with a real answer that how this can be addressed. That is something they will discuss and come up with after their pilot study.
Sir, I think for the Gen AI solutions, we can get real-time regulatory intelligence. Means a dynamic system where you have a proper full checkpoints to see the data quality, governance, access and control, so that on real time you are able to kind of streamline your processes for data.
Yes. Thank you, madam.
Also, the best practices can be captured using Gen AI.
Sorry, is it a question, sir?
No, like, is it a solution? Gen AI can access the best practices from the
Yes.
data, from the database.
Yes. That is also something, that's where RAG is there, right? So best practices, there are two things which generally happens. Very good question. Or other, right? It's not a question, but I can add something to there, that generally the organization sometimes come up with something like what are the industry best practices, right? So sometimes the consulting company, they come up with that these are basically the industry. If you remember, initially I started saying that we have done some secondary research, right, which is outside in approach. So when you're doing the secondary research outside in approach, we are just having that kind of input from other competitors to understand what is the best practices they are doing. And that's where I said, like, if you remember, that hygiene check, health check, that basic fundamental hygiene check. So these are something like with the company, with the bank in question, they are actually following the right practice, right? That best practice, right? Or even not, if not best practice, at least closer to the best practice. So if not, then in that case, the consulting company can always come up and say, hey, this is not the right way of doing that. Then you remember that I also said that we have that X-ray process mining, and you say that this process is not good process, this is a base process, this is something which is something need to be replaced, right? And for that you have to give a reference that this is basically the best way of doing that. Some company XYZ, they are doing exactly that. So thank you so much for even bringing that point, and I added my part. Any other question or anything anybody want to add, please go ahead. So I have a question. So are you finding this thing something which is interesting? It's a real type of example, right? Typically the banks are facing, but if you are thinking that these are very good 2 points that already we have received, but I hope you are finding this case something which is very interesting.
Yes, sir. Yes.
Thank you.
Anybody else want to talk about this? So kindly unmute yourself and talk.
So coming to the risk and limitation, I think data privacy and security could be one of the challenges, sir. Major
Yes.
challenge.
Yes, that is a major challenge. That's why, very good point. Another very good point, madam. That's why if you remember, that's why I mentioned RAG, because the grounding principle, right? So the most of the time, the organization, they prefer their own data source, right? And also their own client data. This cannot be outside organization. So if you are doing some study where you need to get the data about the client which are related to the client, so you cannot, and where you will apply GenAI, so you cannot, there are, especially if you are working in European countries and all, GDPR and all are very, very critical. So obviously data privacy is something which is a big concern, and that's where most of the time that is something also a building block for GenAI. And going forward, that there is somewhere probably there need to be some more work to identify that somehow these things can be taken care of. But data privacy is definitely something which is something very critical towards adoption of GenAI. For that matter, it is not GenAI, but adoption of any technology. It is something like data privacy. So again, if I have to come back to that point of ethical AI, like responsible AI principle, I just want to touch upon here that when you're talking about, for any organization, when they are talking about that, whether it is fair, whether it is transparency is there, explainability is there. So all these things, including data privacy, right? So everything is very, very important, and for any new technology, and then only that technology adoption happens.
Just sir, there is a question from one of the participant.
Yes,
She's
ma'am.
asking which is the best Gen AI tool.
Okay, this is something, this question is very I think nobody can answer this question, right? Because see, there are some, I can only say there are some major service provider, right? But it entirely depends on, finally it entirely depends on most of the GenAI tools are same, if you see at the end of the day. So but commonly people use ChatGPT, but there are different GenAI tools also, like Google also have something, Gemini. So nobody can say vouch for any particular tool, so I also should not. But I think that it is in general, all the GenAI tools are same. But I think ChatGPT, because of its origin and because of its adoption, again I'm talking about that point, adoption. So probably this is more popular, but I won't say this is the best tool. So I probably will refrain myself from commenting on that which is a best tool, madam.
Hello, sir.
Yes.
Yeah, can
Yes,
I have
sir.
a question beyond this case?
Yes, sir.
Yeah. Let us say that we are all for academicians, and let us say our student wants to do a project on climate prediction. So there could be some open source data available. Let us say based on the open source data, a student wants to predict the weather or climate in a particular location, say Bangalore. So can you suggest some ideas which open source data can be used, which model could be used, and how to predict something beyond the data set?
So generally, I have used that earlier. So see, in my research, I generally use real data. Okay, so I go by survey, and I generally with Qualtrics or something where I generally survey questions. Then I decide my scales with which are already established scales and all. Then standard survey, and then we with the use of some structured equation modeling same, or generally we come up with some sort of observation. But this is something which I do generally, which is real data or the survey data. But I know some of my known or my team members, they have worked with Kaggle also. I don't know whether any of you have used Kaggle. Kaggle is, somebody says that they have trustable data, but I have never used Kaggle.
Okay.
Thank you, sir, for asking this question.
Any other questions? Anuradha ma'am, do you have any other question? Okay, Murali sir, then shall we start on the hands-on exercise?
Yeah, there are some hands-on exercises are there. For next few minutes, we can see this. And I also request some of the participants to go work on this. Okay. Last session, I think Abhijit has explored about the XG boost, and now Raja Bas was also talking about the AI and ML into the case writing into the real data. I can share my screen and I can show how we can go ahead with that. So we'll post this data also on the we'll post also this data in the participants folders. You can go ahead. And we can see that I have a set of data. Okay. So before that, let me want to give a small overview about how what is XG Boost actually. Those who are not seen that, you can see in my screen. So XG Boost is an open source machine learning library, which is always used for the optimization, which is called gradient boosting algorithm. For example, if you are working for any predictions, so mostly we were talking about the predictive analytics and everything. So generally, what tool we use for the prediction is we use regression. We use any forecasting techniques like forecast.ets, ARIMA models, these type of things we use to have that. So XGBoost is one of the powerful predicting machine learning algorithm where it is very well known for its speed, efficiency, and high performance. XGBoost is a library into it. You can see here sample data set which we have. You can see there is some historical product demand data I have. You can just see the quality of the data. So how well the data is here. So imagine that you are a product manager. You may see there is something called product codes are available. There are warehouses, various warehouses are there. So J is a warehouse. You can see A is a warehouse, S is a warehouse, and you can see some of the product categories are available. So product category 18, 19, 7. So it is assorted. So we can do some attempt to sort it first. And you may see how many product categories are there. So from 1 to 33 product category are there. We can just make a product category. So dates are available here and order demands are there. So for product number 1938, order demand is 4. And for product number 601, order demand is 50. The thing is, these are all already finished data. For example, the date is very old. So through this product category, through arrows and these demand, we can do a prediction of future demand of the same product. So it might increase or it might decrease. So the regular forecast sheet option might not be sufficient. It's an Excel tool actually. You may see how many data are there. It's a very big data. So there are some 10 lakh data are there here. So it is processing via Excel sheet is not possible. That is what we are using a XGBoost. So XGBoost is a one where the data will be trained, the model will be trained. For example, XGBoost, we can do a train test split model is available. So what is this train? For example, 80% of your data will be trained. That is what we call it as 0.8. And 20% of your model will be tested. That is, we call it as 0.2. So majority of our data will be utilized for training and 20% of the data will be used for testing. So our model is trained, accurate results we can get rather than your forecast.ets or ARIMA models. So this is what we are using XGBoost. This is otherwise called gradient boosting. That is what we saw here. So XGBoost is widely used in data science due to its ability to handle the large data sets because it's an Excel sheet. If I process any test over here in this space, you may see some not responding program will be always happening. So this type of big data cannot be handled in Excel always. The Excel will get collapsed very quickly. So that is the reason we need to find out a predicted model here with a diagram. So that's what's the reason we are using the XGBoost here. Now going back to the script, Python script, what we are having here for XGBoost, you can see the coding, what we have written here for the XGBoost. You may see here what are all the libraries we have used. You can understand about all these libraries. Let me put these libraries in the Google. It will very quickly, it will explain you. So what is this? Just a minute. Okay. So let me show you what all this library will be doing. Already you are doing all these things. So import pandas as a PD, where it's a very, very basic fundamental library where your data will be used, data manipulation and analysis will be done, and data frame is created based on this pandas. The next one is NumPy as NP, where we are doing a numerical computation in Python. That is what it will work with arrays, operations, mathematical operations, and any data science algorithm. Since we are using with XGBoost algorithm, so this is very important. And we want to visualize for each product, we can visualize what is the predicted one. So matplotlib is actually for plotting between X and Y. There will be a plot diagram we can show. And for machine learning and pre-processing, since XGBoost is a machine learning algorithm, we can use this sklearn.processing and XGBoost importer. That is, XGBoost is a regressor where it will predict each and every diagrams. And this is where we were going to do that. And the second step is we are going to upload and load the required CSV file. This is the historical data which I showed you. This data sets, we will upload it directly. And the third step is pre-processing. So usually dates are very, very important for prediction. So year, month, and day, it should be very proper, and week will be calculated. These are all auto-calculated based on the codings which was given. So products code is taken for encoding. So products original code will be encoded, and you may see sort and lag feature. So based on product code, based on date, and based on order demand, the product will be sorted and it will be grouped. And finally, there is something called train test split. That is what I told you. The train test split feature is where 80% of the model will be tested, trained, and 20% of the model will be tested. So this is what we call it as a train test predictions over here. Okay. So we have written on coding for a drop-down filter in the chart. Since we have so many products into it, for each and every product, we have written a coding for interactive, for dropping down and selecting a particular product and looking the prediction trade-off between the original one and the original demand and the predicted demand. Once I run the output, you can see this is where it's all about the diagram. So this is the diagram title. I mean, X label, any label should be given for. So whatever you will type here, it will be displayed. So spikes, you can see some of the spikes in the diagram. So step 10 is a product level summary. So a CSV sheet will be downloaded. And finally, these are all some of the statistical area, MAPI, mean absolute percentage of error. If the MAPE is very less, say like if the MAPE is 5%, we can say that 95% our model is very clear. So usually we give a statistical touch to everything. So when we do anything and everything, we should prove it very statistically that our absolute error is very, very less. And it will show you some top products. So these are all some of the higher level of codings. So this is a template actually. So what we can run it. So it is asking for choose files. We can go there and we can upload our own XGBoost coding. Just a minute. So I'm just going to the XGBoost. So this is the historical product demand which I have. So this is a little big data. It will take some time. You can just see the progress into it. Since some 10 lakh databases are there, it will take at least a minute, 1 or 2 minutes time to getting uploaded of all the total products. I think Raja Basu is also keeping a track onto it, I think so. Okay. Professor Anu, you can add value for these points by seeing the outputs also.
Sure, sir. Actually, just to what Murali sir told, I want to give few more suggestions. So XGBoost is a powerful machine learning model, okay? So it is what happens with XGBoost is it works with structure of tabular data. So just like Murali sir told, the basic concept of XGBoost is on gradient boosting, where what happens is it's actually working like a decision tree. So it combines all the model and finally it will give us a strong predictive model. So when in case of XGBoost, what happens is it will try to build an n assemble of models sequentially. Okay. So each new model tries to correct the errors of the previous one. So iterations happen and finally it will give us the final prediction, which is a weighted sum of all the models. So every time when the Python runs it, what happens is it will try to improve the model. Okay, it will try to correct the previous errors of the previous model. And finally, in the final prediction, just like what Murali sir is doing now, we'll be having a final model where it will be the sum of the previous model. Okay, So what makes this XGBoost special from other machine learning algorithm? Okay. So the key takeaways are like it is a parallelized tree construction. Okay. So what happens is regularization, that is L1 and L2. Okay. It will try to prevent overfitting. When you take other machine learning models like a decision tree or a linear model, what happens is it will try to fit in the data. Okay, but the advantage of XGBoost model or a Puppet model, what happens is it will try to regularize the data and it will avoid overfitting of the value. Okay, that means handling of missing data or a support for custom loss function or a built-in cross validation. So everything happens with lesser human intervention. So when you go for basic forecasting models like SARIMA or an ARIMA, what happens is these are classical traditional models. Okay, and we need to have a lot of human interventions for these models. Okay, but when you take these machine learning models like an XGBoost, what happens is human intervention is less. Okay, and these are powerful prediction model. Okay, so let's see how it works. So when it will try to initialize a model with a constant prediction. Okay, for example, like the mean for regression. After that, it will go for computation of residuals from the current prediction. Okay, the next step will be it will try to fit in a new tree to predict those residuals. Okay, and then after that, it will try to update the model by adding this tree's prediction scaled by a learning rate. Okay, and finally, what happens is it will try repeating these steps until a stopping criterion is met. I told you, no, it will try to avoid any kind of over prediction. Okay, and it will tell us, okay, what prediction is good or whatever final prediction we get is the best. Okay, so it will try to upscale the model. Okay, so it will try to repeat all these steps until our criterion is met. Okay, so that is number of trees or a minimal gain. Okay, that is a main advantage of XGBoost over the machine learning models. Now Murali sir will show us the output.
Yeah, now the output is ready. You can see the actual order demand for product 1359 is this. That is 8 crore, 64 lakh and 22,000 is the order demand. But actual predicted is very less than the order demand now. So the error is the difference between the order demand and the predicted is shown as an error here. So error is actually equal to the absolute error. And you may see the mean absolute percentage of error is 11%. So plus or minus 11% error rate is there and 13 error is there, 40 error is there. You may see predicted is very high and you may see order demand is high, predicted is very less. And this shows that these order demands are earlier and XGBoost has predicted very exactly. This exactness we can see here in the mapping. And you can see here, this is an interactive diagram. We have used Matplotlib. Usually in Excel, we have to make a diagram for each and everything separately. But since we have made an interactive dashboards, imagine if we select a product for 40, the diagram will be displayed only for 40. So if we select 34, the diagram is for 34. You may see the orange color is predicted and this blue color is actual. And you may see actuals are very high and predicted is little less. From this, you can understand that the XGBoost has predicted exactly what's the real-time scenario. It is not like usual forecasting mechanism. XGBoost is very normal. XGBoost is very real. XGBoost is very practical. So you can select each and every product individually. You can see the diagram is getting changed. Also, we got downloaded. Excuse me. Also, it has got downloaded as a summary. Any file output, if you want to inspect it in an Excel sheet, we have written one line as a code here to save the summary as a CSV file. So this is one line, index is equal to false. So it will be saved here while you are in the runtime. If the runtime is disconnected, all these files will be go out. You may see here the product level summary. Whereas you can just do a small analysis here. You may see here, and we can add some interactives. So we can start from smallest to largest. Okay, you can see the mean absolute percentage error is 3, 4 for all these cases. So there is a difference between the predicted and the order demand. So definitely there will be a difference between order demand and the prediction. You may see this is the order demand, this is the prediction. This is where XGBoost is doing this. Hope you all can understand this, right? We can take this results and product-wise summary. If you want to see interactively, if you want to see the diagram, you can see here itself. So here itself it will be displayed. Or if you select a different type of outputs, the distributions and all, if you are publishing as a paper, you can give all these as a diagrams. So anyone can try this in your system. If you want to share your screen, if you want to do this lively, we are ready to give host access to you. You can do it. For any doubts, you can come across with us.
The
Yes.
participant is willing to share your screen. Yeah, we'll be sharing the codes for all the section. So it's already available in the Google Drive link. So you can access it.
Professor Kirti, you raised your hand. Okay, fine. So we will give it. Okay, just a minute. So Dr. Kirti, we made you as a co-host. We can share you this folder with you. So you have a participant folder, right? You can unmute yourself, madam. We can hear from you. Yeah.
Yes, sir. I have the folder which you've shared.
Okay, you can go to my name and you can
Okay.
see.
1 second, sir.
I may have to post it first.
Your folder, sir. Your file.
Yeah. You go on inside Dr. Murli.
Yes, sir. I'm there inside.
Yeah, you can see XGBoost forecasting data and code.
Yes, sir. It's there. I'll download that.
File is missing. Okay.
Is the file okay, sir? Shall I download?
Yeah. It is okay. You can download.
Okay, sir.
You share your screen.
Yeah, I have shared my screen, sir. Is my screen visible?
Visible, but it is showing some Google Colab.
Actually, Kirti, ma'am, you are showing Abhijit's data set, I guess.
Yes, ma'am. In that, I will open this file.
Okay. Please open it. Yeah, we are able to see your screen.
Open notebook. I will open that, no, ma'am.
Okay. Yeah. Please open it. You have already downloaded the file, no, ma'am?
Yes, ma'am.
Okay.
It's there in my downloads.
Sure. Then kindly upload it now.
But
Yeah,
it will be downloaded as a zip file, madam. If you could unzip it, only you can be able to take it.
Oh, sir, it's come, sir.
Yeah.
Oh, fine, ma'am. Then
Yeah, it has come. It has come, ma'am. So kindly run it, ma'am. You can just press on Control A and run it. Yeah.
This one only I will.
Yeah. This one only.
It's running, ma'am.
Okay.
Come down, madam, so that you can see the file upload.
Yes, sir.
Yeah, you can come down.
You have to come to the end of the code. Yeah, now there's an option. Yeah, choose file option.
So there is one use case for marketing also. Yesterday we saw for recency, frequency, and monitoring. So based on that, we brought some prediction for marketing also. There is one algorithm is here.
Now, do I have to choose
Yes, please choose it.
this one? XG boost again?
No,
Yeah, ma'am,
choose
you have to upload
files.
the file, ma'am. Just click on choose files.
Choose files, okay.
Yeah. Yesterday you saw me, right? Choosing a file. Yeah, exactly. Click on it, no?
Yes. Now?
Yeah.
Please choose the historic data demand from the folder.
From the folder. No, from the folder it is not possible.
No, you have to download it, ma'am. If you
download it.
Yeah. Download it and then upload
Folder
it.
it is there, madam. It's there with whose folder?
Yeah, it's already there.
It's with your folder, ma'am, or Dr. Mulli's folder?
Dr. Murali's folder.
Okay. Which folder, ma'am? Historic, huh?
Yeah, that one only.
Which one, madam? There are 6 files. Beautiful Soup, LDA.
No, ma'am.
No.
XG boost, there is a
XG
folder.
boost.
Yeah, XG boost. Okay, you want me to? Okay.
You kindly open that
Historic,
folder.
yeah, historic.
Yeah. Exactly. Kindly download it, ma'am, to your local computer. And
Yes,
from there, you have to upload it.
Okay, ma'am. Okay. Now I'll choose this one.
We cannot see that, ma'am. You have to share
Historic
your
product
entire...
demand, right? This one, no, sir?
Yes, ma'am. That only.
Yeah.
It
Now
is getting. It will take some time.
It says 2 minutes.
It will take some time.
No, it will take more than 2 minutes, ma'am. You can see the progress there up. Okay, it's showing like 5% done, 6% done. So slowly,
10 lakh products are there.
It's
So
reading
it will
your
take
file.
some time.
Exactly. So depending on the data set, the time for uploading also increases. If it's a small data set, means within few seconds, the data will be uploaded. See, few of the participants are asking for attendance link. We'll be sharing by the end of the session.
We have shared a reflective space. There's a Word document in your WhatsApp. We want to hear from few participants. It's a documentation purpose. We need to upload it on a final date. We want it from few participants. You can just edit that Word document, put your name and everything. So few lines you can write the outcomes of this FTP and you can email it to us or WhatsApp directly to us. So it will be very grateful if few of you could please respond to that. And for tomorrow's session, for your information, Professor Satyanarayana Paraidam has shared 66 of his own paper. It is there in the folder. He wants all of you to read at least 1 or 2 papers of his own and come out with any discussion. So more or less, it's a last session. It will be mostly discussing oriented only. So Satyanarayana Paraidam has helped so many research scholars in India by publishing research papers in the top tier journals. So if you have any doubts, if you want to collaborate with him in the future for publishing in the top tier journal, he is always the one who used to help the Indian faculties and the scholars always. It would be definitely a networking for all of you. You can talk with him. And Mr. Murugan will be discussing with all of you like a hands-on from 2 to 5. So tomorrow's session starts by 2 o'clock itself. So please plan your so accordingly, the test will be there for 20 minutes. It's MCQ. After the test, there is a valediction. And after valediction only, we will share the attendance forms and everything. So hope everything will get closed by 7:15 in the evening. Okay.
It seems to be taking a lot of time, sir. The downloading.
Yeah, it will get finished, ma'am. Runtime has got disconnected. I think your internet is
unstable, maybe. But again, it's resumed.
But you have to do it from the first, madam.
Oh,
Yeah.
okay. Okay.
Because the libraries needs to be called, no?
Okay.
Come
Again,
down, madam. Come down.
okay.
No issues,
Again,
madam. It will take its own time. So we have to be very patient on that. No issues.
yeah. Thank you. All the softwares take their own time to.
Moreover, you are running it in cloud, ma'am, Jupyter Lab. So you're calling all the libraries in cloud only. If you want to run, dear participants, if you want to run Python from your local computer, then there is a software called Idle Python, okay, which is being offered by Python only. You can download that software. I've just posted that software name in chat box. So you can download that Python software in your computer, and then from there you can do the coding. Okay, so it will be much easier when compared to running it from the cloud.
Your screen is not visible, browser.
Sir, I closed it so that I start again.
Okay.
So it will be faster, no? Because that's got stuck. So I thought I will start again. So again, I can open the, it will become.
No
better.
issues. You can open directly, ma'am. No need to upload. From the recent it is there. Give cancel.
Cancel, okay. Okay,
From the
from there.
recent you can go for file.
Uh-huh.
Open notebook. Open notebook.
Open
Second
notebook.
view. You can see XGBoost is available already. You click it directly.
Yes, sir. Run.
Now run it now. Come down, madam.
Do I have to choose? No, I choose.
Wait, madam. Wait. Let it get. I think there is some issue. I think so. Otherwise, it would be enabled.
That's the problem, sir. Sometimes the issues, we get stuck. Issues
No,
and
actually, browser is also there is an issue, ma'am. You can update your Google Chrome browser always.
Pardon, sir?
These issues. You can update your Google Chrome browser. If you're using Chrome, if you update it, this type of issues will not be there. Okay. Or you clear your cache files, it won't be there.
Okay.
Come down, we'll see. Otherwise, no issues, ma'am. You can run it in your own time.
Yeah, that's what I will run it at my home, sir. Thank
Moreover,
you. Shall
ma'am,
I
I feel your internet connection is also a bit slow.
Yes.
Yeah, no issues.
So actually, I am also with the video also. I mean, the online session also, no?
No issues, ma'am. You can run it in your whenever you're free and see how the output comes. And if you have any doubts, means do ask us.
Sure, ma'am. Sure. So shall I stop sharing my screen?
Yeah. Please stop sharing your screen.
Yeah. Thank you.
Any other questions from participant sides to Mr. Raja Basu?
Yeah, Mr. Rajabasu, you are here, right? Yeah.
Yeah, Raja, sir.
Yeah, fine, sir.
Yeah. So
if you have any other doubts, you can come across.
Yeah, I'm there. Sorry, I wasn't muted.
No issues, sir. Participants, if you have any queries, our speaker is ready to address.
Okay. So if there is
one of the participants want to share a screen. His name is Avijit. Avijit. Avijit.
Okay, we have to give access to him.
Yeah.
Okay, I'm just giving a scope. Pause permission.
Avijit, sir, we are trying to give you permission. So if you are still interested, means kindly share your screen.
So you have run it successfully. Very good, sir.
Good.
Yes,
Very
sir.
good,
Yes, sir.
You can change the product codes in the interactive chart. So there is an option for you to change. You can change it, the chart will be changing. Okay.
See, based on the products, now the graph is getting reflected.
Okay, sir.
Very good, sir.
Sir and madam, I want to know what is the basic difference between ARIMA, SARIMA, and this XGBoost?
So that's I already explained, no, sir. ARIMA, S-ARIMA, they are classical traditional machine learning models. Okay, so whenever you have a smaller data set and whenever your data is already a structured one, okay, where in that case you can go for a S-ARIMA. If you want to analyze the seasonality of a data set, in such cases you can go for ARIMA or S-ARIMA model. But whenever you want to go for a larger data set, just like the current data set, whatever we are having, when we need to ensure that human intervention is very less, okay, as well as when you want to go for an accurate prediction, okay, as I already explained earlier, what happens with XGBoost is it goes for iterations, okay, or predictions. It tries to build a decision tree like model, and it will try to fix the errors from the previous prediction, so that whatever prediction or final output which we get is the much relevant for our data set. Okay, so it will try to fix the errors by itself, and whatever bias which we have in other models will not be coming in XGBoost. Okay, so our goal will be like a reduced bias model with more accurate forecasting. Okay, so what happens in this XGBoost model is each time each tree learns from residual error of the last tree. Okay, and another advantage is this XGBoost model is faster than other machine learning models. So when you take performance also, we have higher accuracy with tuned hyperparameters. Okay, but when you take another model like a random forest or S-ARIMA or a linear model forecasting, what happens is the accuracy of the forecasting may be down when compared to XGBoost. Okay, so XGBoost is more stable, more memory efficient, okay, on large data set, and it can handle categorical data automatically. Okay. Already, sir, do you
ma'am.
want to add any other points to whatever I've told now?
Yes,
Nothing, ma'am.
actually,
You
I
have
want to
covered.
know whether this model can be applicable for stock market forecasting or stock
Yeah, sir,
price
definitely, you can apply. But again, please check
You
on the
need-
data set or your business scenario or whatever it is, okay? If you have a very small data set, I think ARIMA will be more than enough.
Okay, okay, ma'am.
So XGBoost is for a very big data set.
Okay, for hourly frequency or per minute frequency, like high frequency data in stock market, then we can use it. Okay.
Yes,
Exactly.
it
So
can be
imagine
used.
if you want to analyze your stock data for almost 20 years, then you have a big data with you. In that case, it will be better to go for an XGBoost or an ARIMA model.
Okay. Okay. Thank you.
Okay, if no other questions, we can close the session.
And one more thing I would like to add on is about the stationarity of the data. Okay. So just to add on to the previous question, one of the participants asked me, whenever you have a proper stationary data, you can go for classical models like ARIMA models. Okay. But whenever you feel your data is not good or it's not stationary, in such cases, it is always better to go for high-end machine learning models like a XGBoost or a Prophet. Okay. Okay. Do we have any other questions, or shall we wind up today's session?
Okay, you can formally close the session.
Okay, Raja sir, it was really an interesting session from an external speaker who's an expert in AI and ML. So thank you for sharing valuable knowledge with our participants. And we hope you also enjoyed the session.
Yes, thank you, ma'am. Can you hear me?
Yeah, we can hear you, sir. We can hear you, sir.
Yeah, it's my pleasure, and I really enjoyed it. All the best to all of you. Thank you.
Thank you, sir. We'll connect with you, sir, later.
Thank you.
Okay, thank you.
Okay, so participants, the feedback form is here. So my humble request, please fill this form. Later tomorrow, don't send us any messages. It is very difficult to consolidate the others.
घरे आएगा हम
Participants, you can just unmute yourself. You can
One of the participant has asked a question like when and where we have to submit the reflection journal. You can email to us. Madhuri ma'am, you can email to us.
Anu madam, you can just post our email ID in the WhatsApp group. Don't change the template. Let it be as what we have given. Just give participant name and everything, and we will get from few and we will upload it.
Sure, sir. I'll share our email IDs in the chat box. Give me a minute.
Attendance link will be live for a few minutes, so please finish it.
One of the participant is asking like you are not able to scan it.
It is getting scanned, ma'am. I have scanned. I think anyone is having issue, you can tell me. Yeah.
See, if
Sir,
anyone,
those who
The
have
scanner
joined with
is
the
of
mobile
yesterday's.
phone, they feel very difficult to scan it. If is it possible, you can share the link.
Yes, sir, we can give. Just a minute. Just posted in the chat box, sir. The participants chat are disabled, so you can see the final message as a feedback form only. Please scan the form, or either you take the form from the link. Shall we stop sharing the screen? Have all of you scanned it? Please, participants who are not scanned it, please scan it. So without Google form, referring from the Zoom records takes more time for us to do. So please help us to consolidate the attendance. So it is 250 plus participants. Very tough to cross verify with many. Okay, fine. So we are just closing the session. So
Murali,
thank you very much, sir. Yes, ma'am.
shall we end the session? I think
Yes,
all
yes,
of
we
the
can end
topic.
this.
Okay, okay. Thank
We
you.
can end the session.
Okay.
Thank you.
Thank you, participants. We'll meet again in the same link tomorrow.
Hello, ma'am. Good evening.
Yeah.
I just want to
Yes.
say that I have attended many FDPs, but this FDP is really very, very informative.
Thank you.
Okay.
Thank you, Dr. Ansu Arora. Thank you.
Thank you, ma'am. Thank you for your valuable feedback.
Please convert it as research, ma'am. Utilize your students. You are from engineering or from deemed university or B school, madam?
So I'm from engineering.
Okay, you can just do some interdisciplinary research with any computer science faculty. So they all will be having a good knowledge with all these things. You can get help from them.
Definitely,
And
sir. Definitely.
Anshu,
yeah.
ma'am, kindly fill that reflection journal also. Thank you.
Okay, ma'am. Thank you.
You can send, ma'am.
Okay.
Thank you.
Thank you,
Thank you very
everyone.
much. So hope I'm just taking it for granted that all of you filled the attendance form. Still some 1 or 3 people are there. I think they are not aware about the feedback form. Later, please. Still, if you want, I can be there for another 2-3 minutes also.
Murali, sir, I think all of them have copied the link. And the participants have slowly coming after Zoom link also. Murali, sir? Please, sir, shall we close the session?
Ma'am?
Yeah, ma'am.
Yeah, actually there was a connection, power went off, and I had like, because of that my system also drained out and there was no internet connection.
Now I have
Okay.
posted the form link, ma'am. You can just click it. Yeah.
Okay,
Yeah,
the form.
yeah.
So
Check
I
your
was
chat box.
chat. So this is the form, sir.
Yeah, that one only, ma'am.
Yes,
We open it and fill the form, ma'am.
Yeah, thank you
it's
so
the
much.
last chat.
Yeah, thank you so much, sir, for considering. Thank you.
Okay, ma'am.
Okay, madam, we'll close it. Okay.
Okay, okay, sir. Thank you.